take the attendance. Speakers are Anjusha,
So good morning to all of you. So the plan for the day would be in the first hour, we will try to finish what we were doing yesterday. aka finish the basic studies on the financial stuff on using Python. In the second hour, we'll pick up the case study, which I wanted to take up for today. And we'll invest the second hour discussing what would be the right model to use. And in the second half of the day, we will try to encode part of it, if not all of it.
Ashman,
We will try to avoid use of any GPUs because we are having different machines. So we'll try to encode everything on CPUs. So we'll keep the entire matrix to be simpler. Good. So I believe some of you would have landed here yesterday when we were looking at rolling statistics. To make your life easier, today we will give you most of the codes using Colab because we spent a lot of time yesterday trying to fix spelling mistakes. Okay? But it's always a good start to start coding on your own rather than copying and pasting, at least to understand what each word meant. Good. So we're looking at Apple share or Amazon share, and you might have got something similar, a graph yesterday. So one of the aims for us to look while looking at any time series data, particularly when it comes to stocks, is a very simple question. Should I buy or should I sell? Right? And I have got a time series data. I'm at any one particular point of time. What should I do now? Rather than buy or sell, the question asked is a little bit different. The question is, should I keep the shares which I already have? Or am I incurring a negative return on my share? So I should only keep a share if it's giving me a positive return. Agreed? Alternatively, if the share prices are going down, then so the first order principle would be if share prices are going up, keep it. If share prices are going down, that's not the best idea. But immediate point looking at naive forecast, just looking at one point, something is going down or something is going up, may not be the best approach to look at a long-term view. Now yesterday, while looking at the statistical analysis, we talked about this moving average idea. Right? So rather than taking average of the entire history, you take average of some history. So what we could now do, if we go back to, let's see one of them. So if we now go back and look at the data here, rather than looking at so let's try to find two different moving averages. One which is a short-term moving average with a small number of data points from where we are, and one which is a longer-term moving average. So the longer-term moving average which will be looking at how the share is behaving over a long period of time, and the shorter one will possibly tell you how it has behaved in the last few days or so. Okay? And then we need to decide, so rather than looking at our spot price as to what has happened immediately to our price, what has happened to these two averages? How are these two? Is my long-term average better than my short-term average, or the vice versa? Okay. So hopefully you still have the codes. If doesn't matter, we'll give it to you. So once again, we read the raw data, and now we try to find out the rolling mean for two different Windows frames. We have following again US textbook, and we will try to find, say, two different window sizes, 142, 252. It's a randomly selected number to start with. We'll then later try to find out what is the optimum rolling window size. Okay. So let's just take any one of the share prices. Let's start with Apple because I ran the code with Apple. When it's running with Amazon, life is a little bit tricky, and we will know why it was. And then look at, I've taken two numbers. Why don't you each one of you select a different set of numbers? So take a small number between 20 and 50 for your smaller rolling window, and take a bigger number for the and then plot both of these on the same figure, including the share prices. Okay. So I have got a figure like this. Let's see if you can get something like this. For some reason my animations have refused to work today. So all of you still have your data from yesterday. You know where to read the raw data. Good. If somebody has missed, I can open my Colab file and then we can go from there. Excuse me. Can somebody close the door, please? And after finding these two moving averages, we will try to come up with a strategy of, of an algorithmic trading strategy without human intervention. Can we ask a computer what to do when share prices are behaving differently? So have you been, so any luck in getting these graphs? Or are we all starting from fresh today? Starting from fresh? In which case, then let me share my documentary here. So just to revisit what we did yesterday, for those who were new to Python, we basically included pandas, imported pandas and numpy in our in our code. And then we read a very simple CSV file. Either we download it on our own machine or we can read it directly online. And then all I'm saying is I've created, that's my raw data. And I'm now going to pick, rather than using a data frame object, I'm going to use a series. So I'm just going to pick one of these and then just create averages, as simple as that. Now for those of you who are, let's see if my short link still works for today. Because if you have got computing access, it may not be a bad idea I give it to you directly. It works. Works, doesn't work? Works. Good. In which case, if you want to go online directly, that is a short link and it will provide you the access to the code. Short url.at/olrlq. It is still smaller than the passwords we have here. Or use the shorter one, don't try to type the whole long. So if we now see, I will trust that you will be able to get a graph waveform like this. So if we now see conceptually something interesting is happening. My long-term average, my short-term average is kind of following the share prices, right? If you look at my orange line, it is following the blue line here. Which is not surprising because we have given a shorter window for it to look in the past. Now my long-term average behaves differently at different point of time. Sometimes it's lower than short-term average, sometimes it's higher than short-term average. So now comes the question, how do we use these two figures to determine our trading strategy? The answer is kinda given on the screen, but I would still like you guys to think about it and give me feedback. So if my long-term average is worse than my short-term average, what should I do? And why? You guys are not going to be investors, are you? Or at least you're not thinking of being one. So I hold a share right now. Its market value is more than what I paid for it. Should I sell it or should I keep it? Keep it. The market is doing better, right? If I sell it, the market improves tomorrow, I will be in a loss. So this is called the long position. Okay, I'm keeping whatever I hold. On the other hand, if my short-term market is worse than my long-term market, what should I do? Still keep it. Well, we have somebody who doesn't want to do anything with whatever investments she have. And that's actually not surprising. A large number of investors, particularly in the Indian market, are people who try to keep things over a longer duration of time. So rather than keeping it, well, we can keep our shares. Let's try to figure out another strategy. How about we sell shares which we don't have? Precisely. Well, if we think in the longer term we can buy a share at a lower price than what the market is giving right now, then I can offer to you saying, I will sell you a share at 10 rupees, when I myself would be able to buy it for 9 rupees tomorrow. You will commit to buy it at 10 rupees from me today. I will buy the shares tomorrow at 9 rupees and sell it to you and make profit of 1 rupees. Now, in the bigger industry, okay, let's just not talk about shares. Let's talk about wider commodities market. Uh, Say I'm an airline industry. What are my costs? I have to pay salary to my staff members, which I know. It's kind of fixed cost, and I know how the pilot salary and the air hostess salary is going to go up or down. What is my other big cost? Fuel, right? And the fuel prices go up and down. And that makes my life quite miserable in predicting what's going to be my revenue for the year. So rather than trusting the market value, it may not be a bad idea for me to talk to a fuel supplier and say, hey, you know what? Whatever is your price, I will pay you 2 rupees extra, but commit to that price for the next year or so. Right? Now, if I think oil prices are going to go up, I'm actually making a profit, because tomorrow the oil prices will go up overall in a span of 1 year. I make profit. If on the other hand oil prices go down, then I suffer a loss. Right? I don't know how the energy market works in India. Do you guys know how you pay for your electricity bill? Are you in a firm commitment that the prices will remain same for the next year, or they can change at any point of time? So it's a very market driven strategies. Okay. So quite often in Europe and other places, energy companies try to, because do you have a competition in the energy sector here? There's only one provider, you have many providers of electricity. So you have many providers of electricity. So it's an area driven. So if I live in a house, I do not have a choice which one I buy electricity from. So in many open market economies, what they have done is the infrastructure is owned by one company, and people who supply you could be one of many. So they buy electricity from the supplier. So it goes through the same electric cables to come to your house, and then you have a choice to pick which one of these you use. The same happens for telephone network, or for that matter in the British railway system for the railway network. So in India, the Indian Railways runs everything. It runs the track, it manages the platforms, and it runs the trains. A few years ago, they tried running commercial trains. IRCTC, an arm of Indian Railways, was trying to run trains which were considered more like a private company. So you can imagine a situation wherein tracks are owned by one company, but two different companies ply the trains on the same thing. Something which we see in the bus network. The roadways are owned by the roadways people, but you have different bus companies competing for a customer. Right? So in a similar fashion, you can have a market for energy or market for any infrastructure driven things. Whether it's a good thing or bad thing, that's a very debatable thing. If you ask economists 30 years ago, in 80s and 90s, it was a good thing. Everything should be open. Right? The more the competition in market, the better resources, better return the customer gets. However, what has been seen, particularly in the British sector, that yes, the customer gets immediate returns very quickly, but then the long-term decision making gets further delayed. Also, long-term maintenance of the track, long-term maintenance of the infrastructure. That is because when many companies are fighting over a resource, what's the immediate aim of a company? To get profit for its shareholders. Particularly say for an electricity company, the aim is not to provide electricity to you. The aim is to make money for its shareholders. And shareholders are not going to wait 10 years for their return. Whereas infrastructure development, say if you're trying to make a new dam or new wire line, that takes a longer period of time. So because of this market, immediately you gain and benefit, but in the longer term, the customer starts losing because the customer has to throw more money to get the infrastructure at the same place. I know we are talking about Apple shares here, but there is something interesting which has also happened in the airline industry in India. So what has happened in last 20 years? Can somebody summarize the whole marketplace of airline industry in India? So what are the big players left now? And that's about it, right? There are some smaller players which are SpiceJet has written, and then you have Akasha Air which is also doing, but they are comparatively smaller. So what was the case 20 years ago? So we all started with a single company, right? There was just Air India to start with, and then we liberalized the market. So if you look at the history of Indian airline industry, the sheer number of startups which have come over the years and collapsed over the years is strange. If you visited India because I take a snapshot every 6 months or a year of the airline industry in India whenever I have to fly to India, and I have to book the cheapest ticket possible. I'm still a student in my mind. So for 3 years ago, or just before COVID hit, you had a multitude of options, right? You had Go Air, Air India Vistara combination merger had not happened. Asia was already a fighter. So we had a lot of market choice, but now our market choice is very diminishing. So at one hand, the market worked brilliantly. It brought loads of choices and the competition led to each one of us benefiting, the end customer benefiting. But the shareholders did not benefit that much. That's why the companies kept on collapsing. And as a result of that, we have kinda ending in a monopoly again, aren't we? When I was flying to Jharsuguda, there was only one airline to pick from, and that airline could have charged me 100,000 rupees and I would have given it. Okay. So for vital resources, it's still an open question for things like transport, electricity, telephone network. If market economy is the ideal. Now this is my theory, and I may be completely wrong about my theory. I'm not an economist, so engineers should be very shy of giving theories in other fields. But hey, we are engineers, we always think we are the best of them all. So my theory has something to do with entropy. You know thermodynamics, remember entropy? You guys are earlier year of engineers, so you should know what. So I believe if you leave any system, it will go bad. So if you have a single monopoly system, in due course of time it starts behaving badly. And a very good example is Indian Railways. There has been only few years when it has made profit for its shareholder. Who is the shareholder of Indian Railways? The government of India, right? Now it has a monopoly on a big track part of transportation in India, right? There are, if you have to go to Delhi and you're not in the flight sector, the only option is the railways. It also has a monopoly on large goods transportation in India, things like coal transport or anything, because road network is not terribly great in many parts of India. Despite all this, it does not make that much of a profit. And think of it this way. We have got these two terminologies, which is I've only seen here. There's something called waiting list and reservation against cancellation. So you have customers who are willing to give you money and you can't provide them the services. Think of it, if there's a bus network, there will be another company which will come in and provide a bus. Yes, there are people willing to go, but we can't do that in the railways. Of course, there are other limitations which the railways has. It's a government firm, it can't increase the fares tremendously. It has to do the social good. It has been very good in doing the social good. But despite having a monopoly, it cannot provide you everything. Right? So that's a bad part of a monopoly. And the same thing was true with Indian Airlines. Many years ago, when I lived in Northeast, if you had to fly, you actually get in touch with your MP or the minister to have a word with the Air India officials to give you a ticket. You had the money. Can I get a ticket to go to Delhi? Same was true for telephone network. To get a telephone in your house, you had a long waiting list. And now, getting a SIM card has to be the easiest thing on the planet Earth. So we went from now one monopoly to a market-based economy. And when complete market-based economy happens by itself, then that also starts deteriorating. Remember, I was talking about non-investment in infrastructure, particularly for water companies in UK. So if you leave a pure market-based economy, in due course of time, it deteriorates as well. So my personal take on this is market is neither good or bad. It's just not perfect. So what you need to keep on giving is you need to keep on giving the reality doses to the market from time to time. So we need to keep on going from pure market to pure government run to pure determined, and this pendulum should be swinging from time to time. Or else if you leave any one of them, things will go bad. Neither of them is good enough. And that's my 2 pence on it. Most probably I am wrong. An economist will come someday and kill me for stating something in their field. But that's what it is. Good. So we decided, coming back to our time series data, we decided that in a situation like here, wherein my short-term moving average is doing much better than my long-term moving average, it will be better to keep the share, right? Or have a long position. When my long-term average is better than my short-term average, it's better to short sell it or short the shares. So as a result, we get these windows. Now ideally, the only small amount of time when we are actually doing a transaction, right? So in all of this time, this window, and this window, we should not be doing a transaction. We should just keep the shares. Now here comes the catch with all of these software driven terms. So quite a lot of time we are going to assume that there are no costs involved in doing any transaction, which is actually not true. Every time you buy or sell a share, you have to pay commission to the person, you have to pay taxes on the profit gained. So we're going to assume all of this does not, if all of this does not exist, then what we should be doing is keep the shares long here, and do exactly the opposite of it. So if I now define a position vector, my position is +1 here, +1 here, +1 here, so +1 for keep, and -1 for shorting. So we can then define a position vector, as I said, which will be depending upon if my short-term average is bigger than long-term average, keep the shares, otherwise do a short. Then I could define this thing. So this is what I had a window space for Apple, and this is my window space for Intel. Now Intel is a much more older firm and it has gone through more ups and downs. Hardware sector goes through different transitions, and what we are now seeing is we have got a very small window sometime, particularly when the difference between the short-term and long-term moving average is not tremendously big. So this pure blunt two-way strategy of saying as soon as one is bigger than the other, go short, otherwise keep long, may not work terribly brilliantly always. So let's run this code. So you guys should have written I have to log in now. Brilliant. Which my log? Or should I trust your system? Can I share my machine? Because then I can run it nicely. Actually, let's go through it and then we'll come back to it too. I will be able to log in and see if we can run it. I can show it to you guys for running. Okay. Now, if we go by this strategy, so till now you know, so what we have defined is that we have defined a position vector here that we will long or short our shares, and now we need to know. So that sounds like a good strategy, But does that strategy actually make us money? Now, in order to do that, we can do a bit of backtracking. So say we have done this. What do we make? What's the difference of what this girl said right in the beginning? We don't sell our shares, we keep our shares. So that will still lead to some return on investment, right? If the share, because Apple has done quite well. So we bought it here at 2011. Right now it's already gone up. So we have gone from 40 to 180. So had we kept it, we would have still made a decent return. So having kept it or having gone long and short in between, does that make us money? So the one way to check that will be to identify a returns vector. And now we are looking at the log return. Remember yesterday we talked about percentage change in share or log change in share. So we need to define a returns series, and then we just say, okay, for long, our strategy is simple. We go +1, -1 if we suffer loss. And we multiply these two to find, if we go by this strategy of shopping, what will be my return? So my classic return is just the log return. My strategic return is it's +1 when I'm long, it's -1 that times when I'm short. Okay. We remove all the NAs, and then you just add up all the log returns. So the code does, let's see if possibly I can run it from here, and then that can. So this is for Apple here. No, it's not for Apple. It is for Amazon, is it? Right, then let's change it to Apple. Give me a resec. I'll run it on my machine and then still connecting to Google Compute. Initializing. Connected. Right, so hopefully if I save it, if I am lucky, it would have. Yes. So I have got a window like this, which you can see. I have got areas when I should be going long, a large number of areas, and just 2 short areas when I should go short. So if I follow the strategy, if I just follow the waveform as it is, my return will always follow the share's return. So log return of the share, if I follow the strategy, I will have a positive return. I will just multiply it negatively here. So if I now look at my total return over the entire period of time, if I left it as it is, I would have got a return value of 4 some units. If I had followed the strategy, I would have got 5.8. Using these two numbers of looking at the moving average. Okay. And this is what happens to my return. If I now plot the return, what we have done very simply is just looked at the cumulative sum of return, because return is not 1 point, so I'm looking at how my return adds up over a period of time. Don't worry, you guys will have access to this code so you can play with it later as well. And this is understandable. So initially my returns and strategy follow one another. So in this period of time, I'm keeping my shares long. I'm keeping them, I'm doing nothing. Okay. In this window, I'm going short. So had I not done anything, my returns are a certain value. Because I'm selling short, my actual return following the strategy is exactly the opposite of that. And see, this is -1 times this waveform. The orange one is negative. And then when I again become long, my strategic return follows my default return as well. So it's the two ones are exactly having same slope. It's just because I have gone short here, I have got a boost. Okay. Once again, I go short in this region, and my strategic return is inverse of that, or -1 times multiplied. And once I come back to doing long again, both of them follow one another. But over a period of time, by doing this strategy, I actually have ended up making a higher return than had I made the return by just following it. Okay. Now I started with these two numbers of short moving average and long moving average, 42 and 252. The question, of course, to be asked is, what's this number? How do we learn this number? Okay. Two ways of doing it. Either we can do a neural network based approach, where we can go and say, okay, fine, this is what has happened in the past, see what's the most optimum one. Or if we are lazy, we can go a brute force iterative approach. So that's the first approach which is shown here. And the idea is essentially this. For both SMA1 and SMA2, the moving average, the short moving average and the long moving average, I just try with a large number of. So we go from 20 to 61, and for the long one, we go from 180 to 281. We just try with different numbers and see which one of them gives us the highest return. And if we do that, so the return ratio which we had with the standard strategy. So we go from about 0.25% gain or 25% gain to almost 200% gain by picking a different number. So 40 and 190 would have given us the highest return. Okay. And this is just by brute force applying on something. Now here comes the caveat. We only worked on Apple shares, right? Can we use the same strategy for another company's share? Will the same thing work for Intel or Amazon? Will the same thing work on Apple at a different point of time? Because may. Well, if you say completely not, then we are pretty much defeating neural networks completely, like learning-based systems. So you are right. The problem of these is what we often end up with, some sort of overfitting. Parameters which work very well for a given time series data, and they will give you a fantastic return for one share, will be so bad for the other share that you end up making losses. They may even be in bad for the same set of shares at a different point of time. So mathematically it looks fantastic. Yes, if I go long and short, I make more money. But this again dependent on our choice of these two moving averages. What is actually a short window of looking at data? Is it a day? Is it a week? Is it a month? And in real practice, there are other factors which are influencing it as well. So question to be asked then is, say Google and Apple, they're both kind of similar companies. Okay, not necessarily. One is a search engine based firm, other originated as a hardware firm, but both are having similar space to operate in. So are they influencing one another? Where does Apple makes its money from? Sorry? Devices. Like devices like computers, handheld, mobile phones. Where does Google makes its money from? Search engine. It also tries to sell handhelds. So is it reasonable to assume that Google comes up with a very good phone? The Apple it's not reasonable to assume. She has given Google cannot make a good phone. End of the story. Pardon? Ooh, that's an interesting question. Sorry, guys, I have to discuss this. So use the word security and Apple together. So why do you think Apple systems are more secure than Google systems? You mean data privacy. So these are two different words, guys. One is security, saying how secure is my device? Can somebody else takes my device? Another is privacy. My company is taking data from me. How private is it going to keep that? Okay. Sorry? So is that a fact or is that a market strategy which they have identified? But if I am Apple, I know I have got loyal customers like you, some of you. I can charge anything and you'll pay for the white phone. Or in the next year, I will go for slightly grayish phone. And if I want to make your life nice, oh, this year we'll have a dark phone. So think of it 2 generations ago, till Apple came up with its own hardware. The processor used in Apple laptops was exactly the same as processor used anyway. They were Intel based machines. Right? Now I agree from you from a software perspective, at least in the computing world, Mac as an operating system, because it's based on Linux or based on Unix, not based on, say, based on Linux, there will be a big copyright rivalry going on between these two. So, but Apple is based on, the Mac OS is based on the old BSD Unix. It may be considered to be more safe than Microsoft based systems. Now, it's not, Microsoft based systems are not unsafe. Let's be very clear. It's the end users who are unsafe. Right? Very few times in our history has the computing infrastructure itself been hacked. It has happened when there are viruses and bugs in the code, but bugs in the codes are rarer than actually we sending you an email saying click here to get your Janma Kundi and you click there and give us everything. Right? So the end users are of a different species, the two end users of different. How many of you use Linux here? 1.5%? 2.5%. So I would like to argue that Linux is the safest operating system and the most user-friendly as well. Rest of all, you are smiling. Linux user-friendly. So we used to have this buzzword about Linux. Linux is very friendly. It's just picking about which friends to choose. Once it selects your friend, it's quite nice to. So we are coming back to the market pricing of the Apple. Apple has done a very good marketing strategy, no doubt about that. And they sell very good products. So I'm not going to complain about the product strategy of these two. What I was going to say is, hypothetically imagine Google comes up with a phone which is better perceived than Apple in the market. Actually, this is what happened about 10 or 15 years ago. When all of a sudden a company which used to make computers decided to make a mobile phone. And the then market leaders of mobile phone world, Nokia, Samsung, had a culture shock. This is when Apple decided to enter the mobile phone industry. It was not a mobile phone company in past, right? So now hypothetically, let's assume Google comes up with a better phone or better in market. I mean, their phones are fairly decent. I will never complain about Google. They have a longer lasting shelf life than most other phones I have ever used. They last for a longer. At least they give you 7 security updates, the newer Pixel. For 7 years, they will provide you update. How many years does Apple provide update for? No, they do provide update for few years. I think, pardon? 2 or 3 years is, I think, their 4 years might be the number because I don't use Apple on phone industry. So the question here is this: if somebody comes up with a better phone which starts attracting market, or one of these Chinese manufacturers, who gets to lose the market? So that person's share prices are going to be related to my share prices. The whole discussion we did was we right now analyzed Apple shares as if it's the only share in the market. It's not going to be influenced by anything else, which was a bit of a incorrect assumption. But also the only assumption we can make, because we don't know what is going to affect it. I mean, okay, one logic I said was fine, there might be issues related to market, there might be other players who could come in, or one of the existing players. Samsung finally makes a very good phone which lasts for 10 years. At the same time, there are other factors in play. For Russia-Ukraine war happens, the supply of rare earth metals to make chips gets diminished, and all of a sudden all the hardware companies are in trouble. So my original bread and butter is chip design, and we suffered quite a lot in coronavirus times because all the engineers stopped working. Software engineers can work from home. Physically manufacturing engineers can't work from home. We haven't come up with that, the V-type interface. If you have to put a hammer, do this thing in your home, and a hammer gets ticked in the factory. That will be ideal, but we haven't come up with that yet. We reached that extent that Vauxhall, one of a large car manufacturer based in UK, they stopped using digital speedometers and went back to the analog ones, because analog ones they were there in their factory. The digital ones were not coming in. So when we make chips for AI, our general supply time is about 3 months. During coronavirus, we are having supply times for about a year. And some of the chips we haven't got back with the ones which we submitted that time. So there are other factors which are in play. So the best assumption which we can make is the market is perfect. We have no transaction cost. And this is the only share in the market. Do some approximation and then put a noise on it to contribute to all other things which are happening in the market. Because anything else will make our system too complex. Of course, the more complex the system we have, the better prediction we would have. Okay? And this leads us to the second issue of data correlation. So we talked about Apple and Google having some sort of data correlation. Maybe Google and Microsoft would have also some sort of data correlation. They're both software companies operating in slightly different space, but they share quite a lot of space either. Sometimes it's difficult to see what kind of data correlation which is there in the market. So if we go here, let's look at the whole thing back again. Remember the 12 figures which we plotted? There should be somewhere here. Here, yes. So VIX is the volatility index. Can you see it looking similar to any one of others, or being correlated to any one of the others? So just by visualizing it, it's difficult to find this. However, if you ask economists, they know volatility is opposite of being stable and calm. So if something is stable and calm, the volatility index will go down and vice versa. And if you're looking things like the Standard & Poor 500 index, they are measuring 500 different shares. Right? So there should be an inverse relationship between these two. And we can't see that here. For one reason is that these numbers are different for each one of them. And if I plot, say, in this case, we plotted, my apologies for moving a bit faster, the Standard & Poor S&P index versus the volatility index, I don't see any correlation here. But if you plot them differently, you might see as my volatility went up here, something happened to this. And same again here, every time my volatility went up, my SP index started going down. Okay? So even though the fact they are on two different scales, this has generally been constantly increasing, they are inversely correlated with one another. And actually, if you plot them for a smaller window, you can see that there is a decent inverse correlation. Every time my volatility goes down, this SP index goes up. So that could be something worth looking at with normalized data sets. Explore this. Again, the code for this will be provided for, so I'm not forcing you guys to do much of this thing. So in order to find correlation, remember we are interested in returns rather than absolute changes or even absolute values. Okay? So we are not interested in what's the value of a share, but if I have this share, what am I going to get out of it? Not the exact money. So one idea would be calculate the log returns first and then find these volatility clusters. So if you do that, if you do the log return value, so this was just plotting the absolute numbers, and if you plot the log return value, then it starts looking very, very correlated with one another. Okay? Good. I think my friend's entry here was a sign for me to stop talking and take a break. Or continue? Okay. Generally, when you walk in, you always ask me to stop. Okay. One more thing which we would see before we stop time series analysis is actually I've plotted the same thing in scatter plots, and you can see that there is a very decent relation. It's inversely related relations. If I plot my volatility index on the y-axis and my Standard and Poor index on the x-axis, that looks fairly linear. Good. So this is what I thought we will talk through. I'm kind of hoping this kind of codes you guys will be able to write on your own, so I'm not going to force you to write it. So how many share prices did we look recently? We are looking at 4 different companies, right? And how many data points we had? Roughly 200, or was it 2000? So it was still a small data set, right? Now let's try to do this, and this will be a task for you now. So now we are going to download a high frequency data, the TIX data. So a very good high frequency data is a currency conversion data, because that changes pretty much every minute or every hour or so, or every second. So from the same web page, remember from where we downloaded the previous data set, you have the web page link. So use the first part as the same web page, and then you have got a different file to download here. Actually, should I be able to let me put the full path here, okay? So that that should work. Let's see if it works. Kind of works. So from the same web page, or if you can't download, I will give it to you. Please download this file. This is a high frequency data. And then what we would like to do is to resample this data as 5-minute interval. And let's look at the time which our machines take. Okay. So let's read that CSV data. First download it, read it. And the exercise won't be very difficult because we've already done something like this. I'm not going to give you the code for this. Let's see it, read it, and then just plot it at 5-minute interval. And once we are done with that, we will move on to our case analysis. What's the time now? Is it 11 o'clock already? Okay, now I will take a break now for at least 5 minutes while you guys try to download the file. Can you plot it in 5 minutes interval? Do we have your all emails somewhere? किसी के पास होना चाहिए, right? So in the lunch break, I will dig all your emails and we will send you the data set as well as the research paper. Okay? And then I will leave an hour completely in the second half of the day for you guys to discuss, form groups. I will come and talk to each group and then we will see where it goes from there. So, have you been able to plot something in 5 minutes interval here? Good. Now tell me, what should be the strategy? When to buy euro, when to sell euros. How can we come up with an algorithmic strategy? Should it be instantaneous? Every time euro goes up, because you'll also have some transaction time involved. Just on the day I'm teaching, they decide to bang things. Good. This leads us to our first case study. So even though we will not be doing all the case studies in detail, I will go through the fundamental questions here and we'll discuss. So the first case study which I wanted to explore to you was very simple question. Will my customer come back? So I have sold something to a customer. Will he or she come back? And there's a vital question for any business relationships to ask. The paper to read is a paper which we published. This was to predict customer choices based on price recommender model. It's a bit longish paper. The link is there. We will send you the link by email today as well when I collect all the emails. Okay. So let's make this question a bit broad and ask 3 questions. How do we know what our customer wants? Because he or she will only come back if we know what he or she wants. Right? And once he's there in our store, how do we force or convince or excite him to buy more? And once he or she has bought something, how do we ensure he or she is retained? He or she does not go to somewhere else. Now, this is a very broad question. That's the entire question of field of marketing is there. We have to narrow down the questions because these questions will be asked differently based on what kind of shop I run. If I'm the only photocopier in the local market, I have a monopoly. People will come back to me. But if I'm selling vegetables and there are 5 other vegetable shops nearby, then I need to think very carefully. Okay. So one of the problems for data analysts which we have, or data-based people we have in this world, is even though people buy a lot of things, you all buy a lot of things, from a seller point of view, oh boy, this is going to be annoying. From a seller point of view, there is actually a very much scarcity of data. So let's take the example of clothing industry. Right? We all buy shops, clothes. We don't buy shops. My apologies. We all buy clothes. Some of us buy more clothes than others. Right? But how frequently do we buy this? 2 or 3 months, right? Every festival. Right? So say all of you are my customers and I'm a clothes shop maker. I own a clothes shop. Now I need to know when will she buy more things from me. But she has only bought 5 items in last 2 months. I'm selling 500 items. Right? How do I know whether she will like this item or that item or that item? Unless I know that thing, I can't keep extra stock of it. I can't then go and say, you know what, I think she likes, let's give a very harsh example of Kanchipuram saris. I'll order some Kanchipuram saris and next time she's in stock, here is a special 10% discount for you. But I don't know that. the sheer number of variety of items which even a clothes shop is selling is tricky. But what I do know is overall data. I've sold 10,000 jeans in a year. That I know. But I don't know individual advantage of individual preferences. Okay. So despite the fact the volume is large, volume per person or targeting is very small. The data is very sparse. And same thing goes with bigger industries like electronic appliances. Yes, you buy mobile phones, you buy once in 3 years. So I cannot figure out what you like, what an individual likes. Automobiles, furnitures, these are high-end costly items, and with each one of them, I know a broad statistics. I know overall this generation of people buy jeans as one of the piece of their trousers. But what kind of jeans? Does that person like, the flared up jeans which were popular in 70s? I don't know that figure. And this problem is also true for places like supermarkets. So this might be a bit alien question when we don't have large supermarkets in India. They're still evolving, right? Do we have a larger supermarket in Rourkela? Have things like Vishal Mega Mart come here? They're decent size supermarket. And you have the corner shops, right? The shops which sell everything from battery to toothbrush. They are our equivalent to supermarkets, right? So say you buy 100 items from a product in a month. And generally आप 100 चीजें खरीद रहे होंगे एक महीने में. But उस दुकान में 500 different type of चीजें हैं. Right? आप बैटरी तभी खरीदते हो जब आपकी बैटरी खत्म होती है. आटा गेहूं तभी खरीदते हो, चावल खरीदते जाते हो, बट देन हर का सबका अपना स्वाद है. सो इंडिविजुअल डेटा मेरे पास नहीं है. सो डिस्पाइट अ लार्ज अमाउंट ऑफ शॉपिंग डेटा आई हैव कि इतनी बैटरी यूज हुई, आई कैन कीप स्टॉक. आई कैनॉट डू अ रिकमेंडेशन सिस्टम फॉर माई कस्टमर्स. आई काइंड होप एंड प्रे कि मेरे कस्टमर ओवरऑल ये चीजें खरीदेंगे. इंडिविजुअल कस्टमर को हम रेकमेंड नहीं कर सकते कुछ. Agreed? Good. Now this is not the first time we had this problem. This is a very old problem. But recently we have become more savvy क्योंकि market competition बढ़ रहा है. So how do you attract a customer? A customer should. So पुराने ज़माने क्या होता? There was a personal connection. कि वहाँ उस दुकान वाला आदमी हमको जानता है, हमको overall में 10% discount देगा. बट इंडिविजुअली किस कस्टमर को क्या चाहिए अगर हम ये जान सकें एज अ शॉपकीपर, देन आई कैन टेलर माई गुड्स एंड आई कैन टेलर माई प्राइस सेंसिटिविटी फॉर दैट पर्सन. अगर मुझे पता है कि इनको रसगुल्ले अच्छे लगते हैं, तो द मोमेंट यू सी भास्कर चौबे जी, यू कैन से कि सर आज तो आपके लिए 20% डिस्काउंट है, 1 किलो खरीद के ले जाइए, एंड मोस्ट प्रोबेबली ही विल बाय, प्रोवाइडेड मुझे पता चले कि वो क्या खरीदना चाहते हैं. So sweet shops are nice. They only have 5 or 6 type or 10 types of items. But supermarkets are in this problem. So high volume data bhi hai, but large sparse data set hai. Right? So this is what happens. Then we can divide the products which we have in various bins. We have different types of products. We have batteries, we have food items, and there possibly we can know a bit of customer preference. Now many chains in the Western world, they have started this concept of loyalty cards. Right? So you basically get a loyalty card. The more you buy, the more discount we'll give it. The original idea of loyalty card was कि भैया हमें तो पता चले आप क्या खरीद रहे हैं. But there comes another problem with this. एक तो diversity है, दूसरी है कि जब हर बार आप दुकान जाते हो तो आप different amount of goods खरीदते हो. You don't buy the same currency value or the same number every time you go to the store. So अब ये data collection वाला problem हो रहा है. So we are collecting data. Remember we are dealing with data till now, which were all nice data. अभी जो भी data हमने handle किया वो अच्छा data था. Agreed? It was structured. Very few data pieces were missing. But नाउ आई हैव टू क्रिएट ए मैट्रिक्स. अगर हम एक इंडिविजुअल का शॉपिंग मैट्रिक्स क्रिएट कर रहे हैं तो एक बार में 100 रुपए का, दूसरे बार में 1000 रुपए का, तीसरे बार में 99.5 रुपए का. सो ए आई हैव डिफरेंट प्रोडक्ट्स, आई हैव डिफरेंट प्राइसेस एंड द size of the purchase is different every time. This does not bode well for computation, right? या तो हम डेटाबेस बहुत ही बड़ा बनाए, इसमें बहुत सारे एंट्री जीरो रहेंगे. So there is a diversity of item and there is incompleteness of the data. And then there is also something called structural sparsity. कोई एक कस्टमर सारे प्रोडक्ट नहीं खरीदता, right? Rather, कोई एक कस्टमर मेजॉरिटी ऑफ प्रोडक्ट में नहीं खरीदता. Most customers buy a minority of samples of the product. So now knowing what my customer wants or desires becomes even more tricky. So पहले हम लोग नाइव फोरकास्ट करते थे अपने पर्सनल एक्सपीरियंस से, राइट? सो क्लासिक पर्सनल एक्सपीरियंस था कि सर के बाल सफ़ेद हो रहे हैं, सर अब डाइंग शैम्पू खरीदना शुरू करेंगे. But these are all personal experience, but they are not data driven. Doing any sort of analysis in this becomes very tricky. And that's what we would like to do. So it's a very simple thing. पहले प्रॉब्लम को इतना कॉम्प्लेक्स बनाओ तो ताकि कॉम्प्लेक्स सॉल्यूशन बताएं तो आप लोगों को अटेंशन ले, सर कॉम्प्लेक्स प्रॉब्लम है ही. So let's look at the range. So whenever a purchase is, so let's look at the data analysis. जब भी एक purchase खरीदा जाता है, so the person is buying one or very few product from the same category. अगर हम category separation भी कर देंगे, these are the different types of products which I am having. A customer is only going to buy one of few product, right? So जो total space है of products which I have or types of products I have, the amount of things purchased is a very small thing of the total subspace. Okay? So जो traditional tools हैं computational analysis के या neural networks के, they start finding it themselves very ineffective because things जो नहीं खरीदी जा रही हैं, so तभी हम लोग सोच रहे थे things जो खरीदी जा रही हैं purchased items, but there is a large number of non-purchased items which you don't. Now, if I really want to increase my sale, I have to force you to buy one of these non-purchased item. I have to find a strategy कि आप ये तो 10 खरीदते हो, ये बाकी 5 खरीदने के लिए आप क्या कर सकते हैं. But ये 5 2000 में से हैं. What I also don't know that did you not buy these products because there was no need, you did not like them, or they were too costly, or you did not know that they existed. That's another problem. खासकर स्मॉल सुपरमार्केट्स के जो कॉर्नर स्टोर यहाँ पर इंडिया में या और जगह है, आप तो एक साइज पर खड़ा होकर लिस्ट बताते हो, आपको ये पता भी नहीं दुकान ने रखा क्या है. If suppose the shop has bought say USB chargers, आप कभी जाओगे भी नहीं उस दुकान पे. But product diversification is a classic strategy to increase your sales. हम और चीज़ें डिफरेंट चीज़ें बनाएं, डिफरेंट चीज़ें बेचें तो हमारे सेल बढ़ेगा. और हम कस्टमर को बताएं कैसे? और हम इतने बड़े भी नहीं है कि हम टीवी ऐड चला सकते हैं, राइट? हम क्रिकेट मैच के बाद तो ऐड नहीं कर सकते कि रामू की दुकान से समोसे जरूर खरीदिएगा इस बार, या सरसों का तेल बड़ा सस्ता हो गया, वो भी नहीं कर सकते हम. सो एक काम ये कर सकते हैं कि डेटा एनालिसिस के लेट्स रिड्यूस द प्रोडक्ट स्पेस. हम सिर्फ 10 तरह के प्रोडक्ट बेचें. Now we know from a supermarket that's a bad idea. Because हमारे कस्टमर अगर हम कहें कि सर आज से सिर्फ पॉन्ड्स का साबुन मिलेगा, half of my customers will go. My customer has that big choice model. Actually, this reduction of product space has been tried in past and sometimes it has worked brilliantly as well. So हम लोग पहले दिन हम लोग लेक्चर बात कर रहे थे हिस्ट्री ऑफ इंजीनियरिंग की, उसमें आई मेंशन दिस हेनरी फोर्ड्स idea that he got the. So Ford के पहले cars were handmade. आपको जो कार चाहिए आपके लिए स्पेशल बनाई जाएगी, एंड आपको इतना धनी होना चाहिए कि you can afford a handmade car as well as a driver who will जो आगे जाके स्टार्ट करेगा. And you could have your own color, your own flair, whatever you want. So Ford used to have this punchline that I will give you a car in any color as long as it's black. So he decided I'm going to make black Model T. Everything will be black in color, and I will just make loads of them at a reduced price. I will give you one choice. There will be one brand, one style, but हम दाम घटाएंगे, mass produce करेंगे. To some extent, German supermarkets like Lidl and Aldi, जो value retailers हैं, they have also done it very successfully. उनका है कि भैया हम शैम्पू 10 तरह के नहीं बेचेंगे, एक हाई एंड प्रोडक्ट होगा और एक हमारा अपना प्रोडक्ट जो उसके दाम से काफ़ी कम होगा. एंड फिर आप हमारे प्रोडक्ट से लेते जाइए कि ऑल्डी का प्रोडक्ट खरीद रहे हैं. टू सम एक्सटेंट यू नो विच इज़ द बिगेस्ट FMCG मेजर इन इंडिया. सबसे ज़्यादा रिटेल चीज़ें कौन बेचता है इंडिया में? No, Reliance is not a manufacturer from that point of view. पार्ले ग्रुप, एक नाम आपने कहा, ब्रिटानिया, नेस्ले, फूड आइटम्स में. सो देयर द नेम्स अगर आपको रिंग हो रही है, हिंदुस्तान लीवर, प्रॉक्टर एंड गैम्बल, एंड विच इज द अदर बिग इंडियन प्लेयर्स विच मेक मेनी थिंग्स. लाइक ये लोग सब कुछ बनाते हैं, राइट? साबुन सोडे से लेके बिस्किट तक. Who else who has gone through कि भैया, so Tata, yes, they make a lot of things. In case of Procter and Gamble and Hindustan Lever, आधे लोग जानते भी नहीं है कि हम सर्फ खरीद रहे हैं, सर्फ कौन बना रहा है, right? और बहुत सारे जो शैम्पूज हैं और जो डिटर्जेंट हैं, they are all made by the same firm, but then they have differentiated it. So one firm recently has decided to put its name front and center in all the products it make. और उसके बाद आप ये नहीं, आप सर्फ और एरियल नहीं खरीदते, आप खरीदते हैं कि भैया उसका वॉशिंग मशीन हमको चाहिए, या फिर वो उसकी बिस्किट. It's one of the largest FMCG major in India now. Which one? Patanjali, well done. सो पतंजलि के कस्टमर इसलिए नहीं जाते कि हमारे पास एरियल खरीदना है. पतंजलि के कस्टमर इसलिए जाते हैं क्योंकि बाबा रामदेव सर्टिफाइड है. दैट्स ए गुड मार्केटिंग स्ट्रैटेजी, डोंट गेट मी रॉन्ग, मैं क्रिटिसाइज नहीं कर रहा हूं उनको, राइट? उनकी मार्केटिंग स्ट्रैटेजी बहुत ही अच्छी है. लो प्राइस, हिंदुस्तानी फ्लेवर, मेड इन इंडिया तो सब होते हैं यार, लक्स भी मेड इन इंडिया ही है, भले ब्रांड बाहर का है, राइट? Bringing a shop made in Western world to here will be very costly. Okay? So of course he has popularized this made in India concept as well, and there's this pushing कि भैया, you know, we are the Indian brand, बाकी सब तो विदेशी चोर है, right? So fine, it has a strategy which has worked for them from marketing point of view. और you see business world में कोई खराब नहीं होता. अगर आपने पैसे बना लिए तो आप अच्छे हैं. मोरल नहीं जाता बिजनेस वर्ल्ड में. अगर आप सम ऑफ यू विल डू बिजनेस स्टडीज आफ्टर योर बैचलर्स, राइट? तो मोरालिटी का वहाँ जगह नहीं है, पैसे की जगह. पैसे डिस्कस कर रहे हैं. वैसे थ्योरेटिकली मोरालिटी भी होनी चाहिए और एथिक्स अक्सर पढ़ाया जाता है. सो रिड्यूसिंग द प्रोडक्ट स्पेस कैन बी ए स्ट्रैटेजी, बट इट्स नॉट वेरी गुड फॉर ऑल द मैनेजर्स, पर्टिकुलरली इफ यू आर नॉट रनिंग ए प्रॉक्टर एंड गैम्बल शॉप. उसका तो PNG का शॉप है नहीं, आम दुकानों पर बेच रहे हैं, राइट? इंक्लूडिंग द वेरी फ्यू शॉप लाइक ड्रिंक्स भी लेते हैं तो कोका कोला की अपनी दुकान नहीं है. कुछ होंगी जो सिर्फ कोक बेचती हैं, बट कोक, पेप्सी सब लोग ये करते हैं. एंड दे आर इवन ब्रिंगिंग बैक ओल्ड ड्रिंक्स व्हिच वर डेड लाइक लिम्का एंड थम्स अप नाउ. तो ये हमारे पास प्रॉब्लम है. सो हमने मिसिंग डेटा प्रॉब्लम कहा. इट्स नॉट जस्ट मिसिंग डेटा, इट्स ऑल्सो डाइवर्जेंट डेटा. So I'm just presenting some data to you right now about 4 customers, and this is from an actual purchase data from here. So ये 4 customers हैं who have bought, this is the month of January for them, okay? So water bottles, aloo, meat, lip care, tobacco, canned beans, canned fruits, butter and eggs. I've just taken a random sample of things which they would have bought. And we have looked at who bought what. First thing, you can immediately see there are loads of zeros here. And this looks like a matrix, right? If I think of row matrix versus column matrix, there is lots of zeros here. And then one particular customer, because उन्होंने 200 ग्राम खरीद लिया, have immediately made this number look much bigger than everything else. So if I plot it, I can barely get any information from this inline because I can immediately see this person buying butter. I could have make it 0.2 grams and that would have been nicer. But you know, point-to-point communication between kilogram of potato and lip care per piece is not ideal. Here comes the interesting. If you look at the same 4 customers for the month of February, things are drastically different. It's the same 4 customers. We have gone from January to February. Numbers look very differently. Correlation is limited. Okay. लोग पानी खरीदना शुरू किए. What happened to potato? Somebody bought potato as well. So it's a now. If these 4 customers only had the choice of buying from my store, I can make some sense of this data. But हो सकता है कि वो 5 किलो आलू खरीदते हो, इस साल हमारे से खरीदे 5 किलो आलू, पिछले महीने किसी और से खरीदे थे 5 किलो आलू, मे भी 15 किलो आलू खरीदते हैं, 5 किलो हमसे खरीदे और 10 किलो और किसी और से खरीदे. इशू बनता है. गुड. सो अब हमें कस्टमर बिहेवियर प्रेडिक्ट करने पर हम लोग जाएंगे. सो ये प्रॉब्लम डेटा सेट हो गया. सो प्रॉब्लम सेट, बॉटम लाइन इज द डेटा इज स्पार्स, a lot of data is not there. Now structurally we know the data should be there. ऐसा नहीं है कि लोग खरीद नहीं रहे हैं, तो दुकान में क्यों है, right? जैसे हमने, ऐसे अगर आप इन पर लीजिए, सिर्फ इन 4 कस्टमर्स में से बस एक ने आलू खरीदा, बट ओवरऑल अगर हम 2000 कस्टमर का देखें तो आलू परचेज वुड बी देयर, अदरवाइज दुकान में नहीं. आलू तो खरीदेंगे ही ना लोग, हमसे नहीं खरीद रहे हैं. तो क्या कारण है हमसे नहीं खरीदना? हमारा प्राइस ज़्यादा है, या फिर हमारे आलू सुंदर नहीं दिखते, और पता नहीं लोग. You might laugh, but many supermarkets, particularly in UK, try to ensure कि vegetables are of the identical size, and they throw away many vegetables which are जो उस size के नहीं है, या फिर गाजर जिसमें एक और डंटी निकली हो वो आपको नहीं दिखेगी. So अब हमें customer behavior analysis करनी है. So ये प्रॉब्लम कुछ बड़ा हुआ था आज से 10 साल पहले जब नेटफ्लिक्स आना शुरू हुई थी. You might have heard of the Netflix problem. So प्रॉब्लम वहाँ भी यही था कि 400 मूवीज़ हैं हमारे पास, कस्टमर तो 10 ही देखेगा, 11वां कैसे उसको रेकमेंड करें हम कि भैया आपने ये 10 देखे हैं, दिस इज़ वन विच यू विल सी. And now the problem has become bigger after lots of other chains, like you have Disney, you have so on and so forth, Prime, Apple, and they all faced this problem initially. And the Netflix problem was posed as a challenge. The problem is few people have used it. There's some behavioral data. How do we get out of it? There are 2 approaches which are generally defined. These 2 approaches will work well to understand your customer behavior. Okay? One is content based. So here we look at explicit user profile. तो हमारे यूज़र प्रोफाइल में मंदिर के फोटोज़ हैं और हम राम जी के आगे हाथ जोड़ के खड़े हैं, तो हो सकता है कि संतोषी माता मूवी हमें अच्छी लगेगी, right? So based on my user profile you have item information and user information. You try to match these 2. Okay? या फिर हमने बायोडाटा में लिख रखा है कि इस हफ्ते ओडिशा गए, उसके बाद भिलाई जाएंगे, तो आई सीम लाइक ए ट्रैवलिंग पर्सन, राइट? तो ट्रैवल डॉक्यूमेंट्री किसी की हमें अच्छी लगेगी, एंड दैट्स द वन विच यू कैन रेकमेंड टू मी. बिकॉज एक हमारे पास प्रॉब्लम है कि मुझे तो सारी 200 मूवीज़ नहीं पता है, आपको भी नहीं पता है. तो आजकल मोस्ट यू आर ओनली वॉचिंग वट एवर नेटफ्लिक्स सेज यू माइट लाइक दिस वंस, या फिर जो आपके दोस्त ने कहा कि ये वाली मूवी अच्छी आई है, जो हमारे जनरेशन में होता था. So you can collect a diverse range of data about your customer. It could be images and videos. It could be location. आप कहाँ रहते हैं? Say I'm starting a new shop in Frankfurt, a new restaurant. और मुझे पता चला कि बहुत उड़िया लोग यहाँ रहते हैं. Maybe if once knowing this, I could say, okay, let's make Park Hall one Sunday and see कि भैया बना है. Hopefully they will all come here. family status could be one idea. Uh, Nothing against these people, so my sincere apologies. I'm going to make a very racist statement now. I grew up in a part called Santhal Paragna, which is in Dumka, which is a Santhal tribal belt of Jharkhand. My earlier schooling was from there. And this is, we're talking about 1996 to till 1996. I did my schooling in 96. So who were the most popular cinema stars at that time? King Place. There is no Santhali movie industry, so it is a Bollywood person. Mithun Chakrabarti, well done. Of all these people, his movies were made at a cheap price. But वो एक हफ्ते चलेंगी, प्रेम से एक हफ्ते चलेंगी, उसके बाद फिर अगली मिथुन की मूवी चलेगी. Right? Now he had a popularity in that belt, right? कि very much like the Rajnikant of Tamil Nadu, right? कि छोटा हीरो सफ़र करता है, पीट पाट के सबको ठीक कर देता है. सो मेरा एक जोक हुआ करता था कि मिथुन दा की मूवी में मिथुन दा होंगे, एक एक्ट्रेस होगी, एक विलन होगा और एक कुत्ता होगा. कुत्ता या बंदर होगा, यू चूज द एनिमल विच एवर सेव्स मिथुन दा एट द टाइम ऑफ डाइंग. राइट? सो इट वॉज अ वेरी सिंपल स्टोरी. हमने दिन भर काम किया, हार्ड लेबर किया, हमें अपनी दुनिया से बाहर जाना है. हम इंटरनेशनल फ्लाइट और एल्प्स पर डांस करते हुए लोगों से अपने आप को कोरिलेट नहीं कर सकते, विच इज़ वॉट शाहरुख खान एंड सलमान खान वर डूइंग. हाँ, लेकिन मिथुन दा का कुत्ता, आई कैन सी दैट, हमारे यहाँ भी कुत्ते हैं. ओके, सो चलते थे. Now at that, this is the time when nobody, Mithun Da की movies बहुत बनती थी, but they were not there in the main marketplace. Salman Khan and Shah Rukh Khan were leading this thing. So the family status could also be a content-based descriptor. I don't know if Netflix has figured this out till now कि नहीं, कि Mithun Da का कुत्ता can be that popular. So I can collect information about you, and I know information about the products which I am selling. And most of the local shops जो इंडिया आपके कॉर्नर शॉप्स हैं वो ये काम करते हैं, क्योंकि उनके कस्टमर बेस नियर बाई है. राइट? 200-500 हाउस होल्ड से उनके कस्टमर हो रहे हैं. सो दे नो देयर कस्टमर्स. छोटे शॉप्स हैं, अपने कस्टमर को जानते हैं, उनको ये भी पता है कि अपने कस्टमर को हम क्या रेकमेंड कर सकते हैं. आई रिमेंबर दिस, हमारे यहाँ एक आलू की बरी होती है, टिकिया बनाया जाता है. Remember this shop coming कि ये वाला लाए मेरी मदर को, राजस्थान से लाए हैं, वहाँ पर बनाते हैं. Now this shop was a normal. Why will they bring this? Because he knew that there will be of these 200 people, 50 तो होंगे ही जो खरीदना चाहेंगे. या फिर जलेबी makers. I mean, every Indian household in my part of India at that time bought jalebi makers, despite the fact कि जलेबी सस्ती मिल रही थी बाहर में. तो उसके मजबूरी में हम लोगों ने कई बार घटिया जलेबी घर में खाई, क्योंकि मम्मी ट्राई कर रही थी कि इस बार वाली जलेबी अच्छी बनेगी. ओके, सो दिस द कंटेंट बेस्ड कस्टमर बिहेवियर जानना. द प्रॉब्लम विद दिस इज इट्स हार्ड. इफ यू आर अ लार्ज कस्टमर बेस, इफ यू डोंट नो योर कस्टमर डायरेक्टली, कौन से फीचर यूज करें, फीचर्स को न्यूमेरिकल डेटा में कैसे कन्वर्ट करें. हैविंग एन अंडरस्टैंडिंग कि यू नो इस घर में छोटे बच्चे हैं तो टैल्कम पाउडर की जरूरत पड़ेगी ही, इज वन थिंग, बट ट्रांसलेटिंग दिस इनटू प्योर न्यूमेरिकल थिंग इज अ डिफिकल्ट चैलेंज. सो दिस इज वेयर द अदर अप्रोच वर्क्स बेटर. दिस इज कॉल्ड कोलैबोरेटिव फिल्टरिंग. और इसमें क्या करते हैं कि rather than looking at you, let's try to look at your purchasing behavior compared to other people. एंड ये फिर देखें कि आप किन से मिलते जुलते हैं. राइट? अगर आपने एक्शन मूवी देखी है और इस अलग 10 बंदे ने एक्शन मूवी देखी है, तो लेट्स लुक एट हिज 11th मूवी एंड होप कि उनका 11th चॉइस और आपका 11th चॉइस सिमिलर होगा, एंड देन वी रेकमेंड दैट टू यू. ओके, सो इन द प्रीवियस अप्रोच, इफ यू हैव फिगर्ड आउट आई लाइक साइंस फिक्शन मूवीज, तो आफ्टर द एंटायर स्टार वॉर्स एंड स्टार ट्रेक आई हैव वॉच्ड सब कुछ, तो आपको जो भी अगली मिलेगी एंड्रोमेडा टाइप, आप मुझे वो रेकमेंड करेंगे. या फिर इंडिया से साइंस फिक्शन होती थी शक्तिमान, रिमेंबर? आप लोग को भी देखा है, आप लोग का भी जनरेशन बिगाड़ा है शक्तिमान ने. सो दैट इज वॉट विल बी रिकमेंडेड. ऑल्टरनेटिवली वॉट यू कैन से कि जो साइंस फिक्शन मूवीज देख रहे थे वो नॉर्मल फिक्शन भी देख रहे थे, थिंग्स लाइक वैम्पायर मूवीज. तो इस साइंस फिक्शन वाले ने वैम्पायर मूवी भी देखी, तो होपफुली ये बाकी लोग भी उसमें इंटरेस्टेड होंगे. ओके, so this is what you do about user behavior. So essentially you assume that my users are similarly wired statistically. Now then you aggregate ratings of each product based on the users which जो उन्होंने देखा है, और उसके बेस पर हम आपको रेकमेंड करें. Now इसका एक ड्रॉबैक बहुत बड़ा है जो हमारी सोसाइटी में भी देखने को आ रहा है. Now look at the problem. अब मैं थोड़े एक मिनट के लिए ब्रेक लूंगा, एन एथिकल ब्रेक. ओके, दिस मेक्स मोर सेंस फ्रॉम नोइंग योर कस्टमर बिहेवियर. सेंस बना रहा है कि आपने जो देखा है वही आपको रेकमेंड करेंगे. और दो आर्गुमेंट हम इसमें ले रहे हैं, दो हाइपोथेसिस ले रहे हैं कि आपने जो लाइक किया है पास्ट में, आप फ्यूचर में भी वैसा ही लाइक कीजिएगा, राइट? और आप अपने पीयर्स के बस सिमिलर हैं, जैसे आपके पीयर्स जैसे लाइक कर रहे हैं वैसे वैसे आप भी लाइक कीजिएगा. okay? तो किसी भी प्रोडक्ट की रेटिंग हम सिमिलैरिटी ऑफ द आइटम के अनुसार कर सकते हैं. साइंस फिक्शन दे आर सिमिलर, सो दे आर सिमिलर प्रोडक्ट्स. ओके, और उसके बाद फिर हम एसेंशियल कोरिलेशन निकाल सकते हैं. आई मीन यू कैन मेजर योर सिमिलैरिटी बेस्ड ऑन ए कोरिलेशन वेक्टर की आपने क्या देखा ये. Now that makes mathematical sense, that makes marketing sense. It doesn't make social sense. And this is one of the problems of most recommender systems. What's the aim of recommendation system? What's the aim of artificial intelligence? जब हम लोग लगाते हैं से Facebook का artificial intelligence, उसका aim क्या है? आप लोग रील्स देखते हैं Facebook पर या फिर Instagram पर or anything? No. Well done. No. She gave a very good answer already. To earn money. The entire aim of this system is to earn money for Facebook. Okay? So अगर हमारा एम अर्न मनी, हम अपने आप को ऑप्टिमाइज कर रहे हैं मनी बनाने के लिए. टू मेक मनी आई हैव टू शो यू रील्स विच आई थिंक यू विल लाइक, अदरवाइज तो हम पैसे नहीं बनाएंगे, एडवर्टीजमेंट मनी नहीं आएगा मेरे पास. ओके, सो हम आपको जानना चाहते हैं, बट एट द सेम टाइम हम आपका चॉइस भी रिस्ट्रिक्ट कर रहे हैं. कि आपने क्रिकेट वीडियो देखा, अब आपको क्रिकेट वीडियो ही एक के बाद एक दिखाते जाएंगे. एंड इन रिड्यूसिंग दैट चॉइस, क्योंकि हम भी वही से एक सोर्स ले रहे हैं ना, उन्हीं रील्स से हमको सारी जानकारी मिल रही है आजकल, हम बाकी चीज़ तो देख नहीं रहे, तो हम वाइडर इंफॉर्मेशन एक्वायर कर ही नहीं रहे. जब हम पढ़ रहे थे, दूरदर्शन वॉज द ओनली न्यूज़ चैनल. पहला न्यूज़ प्रधानमंत्री के लिए होता था, प्राइम मिनिस्टर आज यहाँ गए, शायद आज भी यही होता है. दूसरा न्यूज़ इंफॉर्मेशन एंड ब्रॉडकास्टिंग मिनिस्टर का होता है. उसके बाद वाले न्यूज़ ऑल ओवर इंडिया कवर करते थे. कल मैं एक बार्बर शॉप में दाढ़ी बनवा रहा था ना, आई वाज वाचिंग द न्यूज़, क्योंकि साइज में न्यूज़ चल रहा था, उड़िया में चल रहा था, बट यू कैन अंडरस्टैंड इन न्यूज़. एंड सरप्राइजिंगली देयर वाज नो न्यूज़ अबाउट उड़ीसा, एक्सेप्ट प्रधानमंत्री भुवनेश्वर आए प्रवासी भारतीय दिवस इनॉग्रेट करने के लिए, एंड दैट रन न्यूज़. और उसके बाद वॉर के बारे में बात करने लगे, बिकॉज उनको पता है कि संबलपुर डिस्ट्रिक्ट में एक रोड एक्सीडेंट हो गया, कोई नहीं सुनना चाहता, राइट? अनलेस एक ट्रेन एक्सीडेंट हो और 100 लोग मरे, किसी को परवाह नहीं पड़ता. सो रादर देन टेलिंग यू दिस न्यूज़, बिकॉज आपको जानना चाहिए आपके बगल में इंसिडेंट्स हुआ है, हमने जान गए कि आपको तो भैया बस वो मोदी जी क्या बोले वो जानने में इंटरेस्ट, वही सुनाते हैं आपको, तो आपने जाना ही नहीं ये चीज़. The goal of news or the goal of media was to enlighten us. Rather than enlightening us, it has enlightened itself in knowing कि आपको क्या चाहिए, आपको यही देते रहेंगे हम. So at one hand, collaborative filtering works brilliantly from maths perspective. It works very badly for the society. Now अभी तक मैंने अच्छे examples दिए इस bad for the society के, अब इसको strange example दिए, देखे जाए. So people who were of extreme left wing या extreme right wing mindset. And I have seen this very good example in my parents' reel of Facebook या फिर जो भी सोशल मीडिया वो यूज़ करते हैं, क्योंकि ये लोग भक्ति की चीज़ देखते थे, तो इन लोग को रामदेव बाबा का योग का रील भेजने लगे यूजुअली कि ये दोनों इंटरेस्टेड होंगे. और उसके बाद जो राइट विंग माइंड से चलता है, जैसे पाकिस्तान ये कर रहा है, राहुल गांधी अटरली बेकार है, मे बी बेकार है बट इट्स नॉट फेसबुक्स डिसीजन टू मेक, राइट? सो इसेंशियली उस लाइन में वो ये जा रहा है. तो इसको देख के पिछले महीने फाइनली मैंने भी डिसाइड किया कि चलो भैया हम भी फेसबुक रील देखना शुरू करते हैं. लेट्स सी व्हाट डज इट गिव टू मी. इट हैज गॉट नो डेटा अबाउट मी, मैंने आज तक नहीं देखा था. सो इट इज नाउ हंटिंग, राइट? शुरू में आप हंट करें कि ये देखे, क्रिकेट देख लिया हमने तो उसके बाद से बस क्रिकेट पर ही क्रिकेट आ रहा है. इट लुक्ड एट माई एज ग्रुप, मिड करियर एज ग्रुप, क्लासिक मिड लाइफ क्राइसिस वाले लोग होते हैं, राइट? 10 साल शादी हो गई. सो गिव हिम सम सेमी लाइफ चेंजिंग मोटिवेशनल एस्पेक्ट कि भैया अपनी ज़िंदगी सुधारो, या फिर पहाड़ पर चढ़ो. इज गिविंग मी मैनी ऑप्शंस टू फिगर आउट. ऑल आई वॉन्टेड टू डू वॉज, जो मेरी वाइफ रील्स देखती है, द इंडियन कॉमेडी, द देसी कॉमेडी 2 minutes, वो मुझे दे ही नहीं रहा है. मैं कितना भी कुछ करूँ, मुझे दिखाओ वो. इट्स नॉट लिव, इट डजंट नो मी एंड इट्स हेड हंटिंग. एंड इट हैज़ ऑलरेडी पुश्ड मी इन दैट ब्रैकेट कि आप इंडियन मेल हो, इस साल के हो, आपको इनमें तो इंटरेस्ट होगा ही नहीं. आई मीन टू एन एक्सटेंट को मुझे केक बनाना सिखा रहा था एक बार. आई मीन केक खाने में इंटरेस्ट है, बनाने में इंटरेस्ट नहीं है. Good. So coming back to these two models, content-based and collaborative filtering. Content-based is very difficult to infer a user's perception of the content, right? It always demands more computational resources, क्योंकि आपको अपने user के बारे में बहुत कुछ जानना पड़ेगा. Item के बारे में तो पता है. We have made the items, we know the features of the item, right? But users profile के बारे में जानना बड़ा मुश्किल काम है. It's not impossible. Most large social media network already know everything about you, but it's not an easy task either. So then the question comes, can we use customer feedback? Because that's a major part of social science theory. Like, पूछते हैं आपसे ना भाई आपको अच्छा लगेगा या नहीं लगेगा. And there are 2 types of feedback we can take. One is explicit feedback. हम आपसे सीधे पूछ रहे हैं, आपको अच्छा लगा नहीं, बस टिक मॉक मारिए. कभी आप लोगों ने किसी चीज का रिव्यू लिखा है? लिखा होगा एंड 1 to 5 स्टार दिया होगा उसमें, राइट? और जनरली रिव्यू आप लिखने तभी जाते हैं जब अटरली अनॉयड होते हैं उस प्रोडक्ट पर, राइट? अमेजन ने चीज डिलीवर नहीं किया, या फिर ये ट्राउजर लिखा था साइज 40 आ गया साइज 22, राइट? जनरली जब ठीक क्लिक किया, ठीक ठाक रहा, तो बहुत रेयरली आप अच्छा रिव्यू देने जाते हैं. Right? Agreed? So many brands have this problem कि क्या नहीं काम कर रहा है तो पता चल जा रहा है, क्या काम कर रहा है ये नहीं पता चल रहा है. Same with the banks. अगर आपको कोई कस्टमर सर्विस में प्रॉब्लम हो, तुरंत आप रिव्यू लिखने को तैयार हो. तो from explicit feedback or from ratings and reviews, it's very difficult to figure out the explicit feedback. Same with movies. You did not like the whole story chain कि बस ये वाला एक्टर मुझे अच्छा नहीं लगता, right? Or for that matter, what was the status of my affection of the Indian cricket team? So after Sachin Tendulkar generation, I stopped watching cricket for like 15 years. कि सारे दाढ़ी वाले प्लेयर आ गए थे, and I just somehow cannot like. There's a generation of Indian kids who have gone back to beard. So my generation had come out of the mustache. कपिल देव and वेंकसरकर वाले मूछों वाला जनरेशन खत्म हुआ था, and clean 7 generation शुरू हुआ था, Sachin Tendulkar, Majrekar, and all of a sudden they have gone back to and Virat and everyone else. I mean सबको लगता है बस वही एक फैशन मिला हुआ है दाढ़ी बनाने को. So this is very difficult for us to know the content based approach. Okay. और यही स्ट्रैटेजी वो जो आपके क्या कहते हैं स्टोर कार्ड्स भी कई बार यूज करते हैं. प्रिसाइसली कस्टमर फीडबैक इज रेयर, गुड फीडबैक इज रेयर, एक्चुअल फीडबैक इज इवन रेयर, एक्चुअल ट्रू फीडबैक इज रेयर. सो कई बार आपने खासकर अगर आप जोमेटो पर खाना ऑर्डर करते हो तो खाने का कई बार फीडबैक नहीं होता, टाइम से नहीं पहुंचाया उसका फीडबैक होता है. इन जनरल इंडियन खाना बुरा नहीं होता, वैसे अभी तो बुरा ही मिल रहा है, मुझे बहुत मिर्ची डाल रहे हैं सब लोग, मेरी मिर्ची खाने की आदत खत्म हो गई है वेस्ट में रहते हुए. ओके, so the other thing which you can do is not explicit feedback but implicit feedback, right? And this is looking at the interaction between user and the product, not necessarily what the user tells you but what does the user do with it. So यूज़र ने मुझे ये नहीं बताया कि शाहरुख खान काफ़ी अच्छा एक्टर है, पर मैंने उसकी 5 मूवीज़ एक के बाद एक देखी हैं. आई मीन ये दूसरी बात है कि उस यूज़र को उसके बाद साइकेट्रिक इवैल्यूएशन के लिए जाना चाहिए, बट फेयर इनफ, राइट? सो दिस इज एन इम्प्लिसिट फीडबैक कि देर इज ए लाइकिंग हियर, दैट वाज ओनली कॉमन फैक्टर, और मे बी देयर वाज अनदर कॉमन फैक्टर, बट देयर इज एन इम्प्लिसिट फीडबैक जो हम यूज कर सकते हैं. The problem with implicit feedback is this: it can quickly grow to be very large. हम assume कर रहे हैं कि आप ये पसंद कर रहे हो, right? तो आपने शाहरुख खान लाइक किया, या फिर यूरोपियन एल्प्स की सीनरी लाइक की, या फिर गाने लाइक किए. This database could become very big. And what about the ones which you did not watch? Are you having a negative feedback for them? Do you think negatively about these things? You don't know, right? I mean, there was a theory, I mean, there was a paper published which basically said, you know what, rather than looking at positive feedback, let's go all from the angle of जो आपने नहीं देखा, and let's consider that as an important criteria and figure out कि आप क्या क्या नहीं देखेंगे या फिर क्या क्या नहीं खरीदेंगे. What will you not buy? What will you not see? Let's make that as the question, because then that also tells me something rather than just looking at the positive. I mean, there are 3 things, okay, the positive, negative and somewhere in between. अगर दाम अच्छा हो तो खरीद लेंगे ये वाला जैकेट भी, okay? और in generations of there is a mental trauma which I have, जो हमारा जनरेशन जब बड़ा रहा था कि मेरे घर में बहनें नहीं थी, तो मेरी मदर की साड़ी परचेज में मुझे जाना पड़ता था, और वो मेंटल ट्रॉमा मुझे अभी तक है, जो 1 घंटे ये वाला शेड ऑफ रेड नहीं चलता था, लेकिन यार लाल ही तो है, क्या फर्क पड़ता है. Okay? So yes, absence of feedback is often ignored in recommender systems. But absence of feedback is also telling us something. अगर आप देखकर भी किसी चीज का फीडबैक नहीं लिख रहे हैं, तो वेर यू सो डिप्रेस्ड कि भैया इसके बारे में लिखेंगे ही नहीं, या फिर आपने यूज किया अच्छा था, या फिर ठीक ठाक था पर उतना भी नहीं था कि फोन उठा के उस पर कुछ लिखने जाए. गुड. सो now we will go back to this problem. Let's look at this matrix again. So now I will teach you a technique called matrix factorization. So कुछ products के बारे में हमें पता है कि आपने क्या किया, बाकी products के बारे में हमारे पास zero feedback है. तो essentially हमें इस matrix को fill करना है कि जो zeros हैं, could they have been something? And that, so it's a matrix completion problem. The one way to solve that is to do a technique called matrix factorization. And the idea here is to, can I approximate the entire matrix by a fixed function when I only have a partial matrix? By factorization I mean I'm going to get 2 submatrices, the product of whom will somehow lead me to this whole matrix. Okay? Now say I have got my users here and I have got my items on top. I could identify a feature and I can find a relationship between this user and that feature and that item. जैसे हमने science fiction की बात की. So all the users जो science fiction like or dislike, and इस movie में science fiction है या नहीं है, ये 2 feature set में, so that becomes 2 submatrices. And then if we can identify suitable features, the product of these 2 matrices, because now it has become a smaller matrix, right? But a product of 2 matrix, 2 by 2 and 2 by 2 row and column matrix, 4 by 2 versus 2 by 2, the product of this will give me the resultant R matrix. Okay? So that's the whole idea of matrix factorization. There are 20,000 approaches to do it. हम सबसे simple gradient descent approach अभी देखेंगे और शाम को इसको code करेंगे. Okay? So in the Netflix problem, it was the most successful approach to do that, and it worked brilliantly there. It also is now working brilliantly in virtually almost all recommender systems which are there. कुछ लोग अब इसमें ऐड करते हैं कुछ फीचर बेस्ड एनालिसिस आपका कंटेंट जान के आपके, बट जनरली दिस इज थिंग्स, द होल आइडिया इज दिस. आर मैट्रिक्स जानना है हमें, रेटिंग मैट्रिक्स, इसको हम रेटिंग कहेंगे अभी के लिए, और हमें पी और क्यू निकालना है. सो we have some feature space. The idea is what the feature space is immaterial right now, but let's look at those two matrices. So there's two matrix. P is measuring the strength between a user and feature, and Q is measuring the strength between item and feature. Now that your senior person is here, I need to keep a track on time. He's here to take me home. Okay, so we'll do few more minutes and theory explain karenge, and maybe I will explain it again after lunch as well. So the idea is very simple. It's a very simple, the basic algorithm is very simple. वो आप implement कर पाइएगा. The idea is कि let's say P times Q is equal to R, right? Let's start with a random P and random Q. Okay? तो अगर random P और random Q से शुरू करेंगे, तो we can find PQ product. There will be some error between this product and my desired R. होगा ही, because हमने तो random शुरू किया ना. So हम वो error find करते हैं, and we take a least mean squared error, second order error you start करते हैं, because first order error लेंगे तो कुछ positive होगा, कुछ negative होगा, जोड़ ताड़ के सब बराबर हो जाएगा. So अगर हम हर element पर error calculate करते हैं, so Rij minus the predicted Rij square, I get an error square matrix. Okay, and you know your element at Rij is nothing but the product of individual Pik and Qkj. Matrix multiplication आप लोग किए है ना, right? So आप इस चीज को समझिए, summation of all the rows versus all the columns. Okay, so हमें error मिल गया. अब हमें ये जानना है कि अगर हम P को बदलेंगे, P is my prediction, P and Q is my prediction matrix. अगर हम P को बदलते हैं तो error का क्या होगा? अगर एक इंडिविजुअल एलिमेंट को हम चेंज किए तो व्हाट विल हैपन टू माय एरर? तो इट्स अ फंक्शन व्हिच हैज गॉट pik हियर. I can just do a partial derivative of this with pik. So I can do a partial derivative and I get a very interesting function. So it's 2 times this, which is the same as the error. जो हमने error calculate किया, 2 times error times qkj. And similarly I can get for q's as well. So now I can define that as my update strategy. Remember हमने perceptron में भी ऐसे ही update किया था, right? So we find an error and just ये कहते हैं कि भैया ये जो gradient है, gradient को ही add कर देते हैं उस PIK के साथ with some alpha, because actual addition करे तो हो सकता है move करते करते it misses. अगर बड़े steps में jump करेंगे तो जो ideal मेरा location है PQ, it will miss that location, go somewhere else. तो एक छोटा स्केलिंग फैक्टर लगा देते हैं टू स्केल दिस. कभी कभी ये करने से, सो दैट विल बी द सिंपलेस्ट स्ट्रैटेजी कि एवरी एलिमेंट को हम उसके एरर के साथ अपडेट करें. कभी कभी ये ओवरफिट कर जाता है तो हम लोग एक सेकेंड बीटा पैरामीटर से इसको अंडरफिट करते हैं, विच इज सेम एज PIK. वी बेसिकली ट्राई टू इंश्योर कि कोई मैट्रिक्स इन्फिनाइट बड़ा ना हो जाए, because one product will always be कि 0 0 आ जाए, 0 0 आ जाए, मल्टीप्लाई करके हमारा जो 0 था वो आ जाए, राइट? तो इसको स्केल करते हैं एक डिफरेंट बीटा से. Now this is what I want you guys to code. Okay, so we take a small matrix 5 by 3 5 by 5, छोटा ही लेते हैं, और उसमें हम अच्छे खासे zeros भर देंगे. Okay, and then we start with 2 random smaller matrices P and Q and try to achieve that matrix by doing this iteration. ये iterate करना होगा, so about 30 to 50 iteration में हो जाएगा. We'll spend an hour writing the code for matrix factorization. The simplest code नहीं लिख पाए तो मैं दे दूंगा आपको, और उसके बाद हम क्या करेंगे कि we will take a sample, not data, date नहीं भाई, data दिमाग खराब हो गया, रात को स्लाइड बनाने का यही ट्रबल होता है. So this is a ratings database, या फिर हम किसी मूवीज का रेटिंग डेटाबेस उठा दे, tons of databases online. We'll pick any one of them and see if we can use this very simple matrix factorization to predict that. Right? कुछ नहीं तो 20-25 मूवीज का डेटाबेसेस बड़ी आसानी से मिल जाता है, एंड लेट्स ट्राई टू सी प्रेडिक्ट वेदर वी कैन डू दैट. जब एक बार हम वो कर पाएंगे, then the next task we will have is to see can we, so this is will be a iterative cycle, right? हम एक gradient descent ले रहे हैं और बार बार iterate कर रहे हैं उसको. It will take a long period of time. It will also depend on alpha and beta. So दोनों को छोटा रखिएगा, बीटा को something like 0.02, अल्फा को 0.002, छोटा नंबर रखिए. Let's try this. Is there a, can we use some sort of, because essentially what we are trying to find matrices for a residual matrix, right? But we have already done quite a lot of this in past. हमने ऐसे resultant matrix काफी ज़्यादा calculate किए हुए हैं. So using that already calculated matrix, can we learn? So rather than doing this iterative, or in addition to doing this iterative cycle, can we learn how to do this matrix factorization automatically without going through this complex maths? Right? तो उसमें फिर हम लोग एक मल्टीलेयर न्यूरॉन लगाएंगे, मल्टीलेयर, और इसमें वी विल ओनली डील विथ मल्टीलेयर परसेप्ट्रॉन. तो जो हमने परसेप्ट्रॉन हैंडल डिजाइन किया था 2 दिन पहले, उसी का मल्टीपल लेयर बना के we will try to do matrix factorization in a slightly better fashion. और उसके बाद देखेंगे कितना बड़ा database set हम लोग देख सकते हैं. So our project, and then I will give you analysis of what we did. So we essentially also use matrix factorization. और हमारा सवाल हमने ये रेज किया कि छोटी दुकानें किस तरह से प्राइस सेंसिटिव रेकमेंडर मॉडल बनाएं, कैसे आइडेंटिफाई करें कि किस प्रोडक्ट पर हम कितना दाम घटाएं और किस प्रोडक्ट का प्राइस मैटर करता है. अगर आप आलू खरीद रहे हैं तो 10-5 रुपए 10-5 पैसे के इधर उधर का फर्क नहीं पड़ता, बट फेयर एंड लवली क्रीम मे बी इट मैटर्स, और फेयर एंड हैंडसम टू बी जेंडर अनबायस्ड. ओके, सो वी विल क्रिएट अ सिंपल डेटाबेस ऑफ मैट्रिक्स फैक्टराइजेशन. मैट्रिक्स फैक्टराइजेशन करेंगे एक डेटा सेट का, और उसके बाद वी विल डील हाउ टू यूज दिस फॉर आवर एनालिसिस. And maybe even for the sugar problem, you might have to, okay, it's a full data set, but we might have to do some sort of matrix factorization there. Okay? Should we take a lunch break? और क्या continue करूं? ना lunch break लेते हैं. Stop करते हैं भैया. से हटा सकते हैं.
Yes, sir, it's not working. It's not working.
Okay.
If you can walk through this one,
You want me to walk with this one?
you can like walk with some power distance also. Like
Hmm.
capture the sound.
Fine. Well, you're not going to have much conversation now because I'm going to look at people's machine. So the first person to get matrix factorization working will get a bar of chocolate. That's the prize for the day. And I might have to go and walk to a place to buy a bar of chocolate. Keep it initially allow the matrix to take any dimensions. Okay. When you are running it, so you're writing a function most probably, right? Allow the function to take any dimension. When you are testing it, test it for about 5 by 4, 6 by 5, smaller dimensions, but not too small either. Don't go for 2 by 3 or 3. Somebody has already got it working. We might have to not give master student this thing. So this microphone will just pick up the noise of drilling upstairs, right? Fair enough.
কে বন্ধ করলা এটা? হ্যালো, এটা ବି ବନ୍ଦ ଅଛି। এটা କାହିଁକି ବନ୍ଦ କରୁଛ ତମେ? କିଛି ଦରକାର ନାହିଁ ଏଇଟା କିଛି ବନ୍ଦ କରିବାର। ଓକେ, ଡାଇରେକ୍ଟ ତମେ ଏଠି ବନ୍ଦ କରିବ ଯିବ, ଏଗୁଡ଼ା ହାତ ମାରିବନି ଟୋଟାଲି କିଛି, ଚାଲିବ ତାର ହେଲା, ସବୁ ଚାଲିବ।
Thank you, sir.
हाँ, so आप एक स्पार्स मैट्रिक्स दीजिए and your code should give back a full matrix to me, right? Now the way you check it, कि जब आप वापस मैट्रिक्स लाइएगा तो आपने कहीं पर एक नंबर से नंबर 5 दिया, तो आफ्टर फैक्ट मैट्रिक्स फैक्टर्स नंबर 5 won't come, it will come to 4.9 या 5.1. So this 5.1 should be close to 5, और जहाँ जहाँ आपने 0 डाल रखा है वहाँ वहाँ it should come up with a number. क्या हो रहा है? क्यों आइगन डिकम्पोजिशन पढ़ रही हो? तो पूछा क्यों नहीं? हाँ? अभी तक खाने वाला तो नहीं बना हूं मैं. लेट्स सी. सो क्या करना चाह रहा है? गिव मी अ पेन एंड पेपर. Oye, that's cheating. That's cheating, asking ChatGPT to create a function. Yay. यार कम से कम प्रोफेसर के सामने तो चीटिंग मत करो, कुछ तो लिखो. So essentially हम करना ये चाहते हैं कि say somebody gives us this matrix 5 3 0 0. ठीक है? So you can think of this as these are, each one of row is my user, each column is a product. Let's consider the products to be a movie. Okay, so user has given, the first user has given 5 star to first movie, second star उसने 3 star 3, बाकी दो को उसने देखा ही नहीं अभी तक, so he hasn't given any rating. So now this is a sparse matrix. Some of these things are full, other things are empty. Now what we want is a matrix which will have these numbers same as this, but these numbers will be given a number. तो हम लोगों ने जैसे सवेरे देखा कि all we do is we find two matrices P and R जिनका dot product becomes equal to this matrix, where these terms are this matrix and the other terms are something else. Okay, so dot product होगा तो ये matrix किस साइज की matrix है? 5/4 है, right? तो ये कितने की होगी और ये कितने की होगी? So this has to be 5 by something and this has to be something by 4. Okay, 5 into 4. Agreed? Good. So what we start with is a random matrix. Random P, random Q. Okay. Now I have got the values of P and Q from there, and I iterate them many times to update it. And write the code which follows that algorithm, and it iterates till we find. Actually, you know what? Let me also write the error function there so that it will help you. So the good thing about ChatGPT is it does quite a lot of things. बस यही याद रखिए कि अगर आप ChatGPT से कोड लिखवा रहे हैं तो आपकी सैलरी भी वही लेगा जब आप इंजीनियर बन जाइएगा. Okay, so at every step we calculate the error, और उस error को use करके we then go back and repopulate the structure. हो गया? And it's not ChatGPT produced. Mm-hmm. और छोटा दो, ठीक है, बट ठीक है, छोटे मैट्रिक्स के लिए
अपने हिसाब से किए यहाँ पे, और फिर एक प्रेडिक्ट फंक्शन बनाया है, और ये क्या करता है, डॉट प्रोडक्ट निकालता है पी और क्यू का, और क्यू का ट्रांसपोज का. तो ऐसे और इसका मल्टीप्लिकेशन मैट्रिक्स हो गया. फिर अब इटरेट करेंगे जहाँ पे आर का वैल्यू 0 नहीं है, वहाँ वो एरर कैलकुलेशन कर रहा है. और उसके बाद और जहाँ पे है वहाँ पे एक रैंडम वैल्यू दे रहा है, और उसके बाद फिर हम लोग प्रिंट करवाएंगे ये वाला फंक्शन
एरर यूज करते हुए. ओके,
फिर प्रिंट करवाएंगे.
बट आई नीड ए न्यू आर. कितना बार इटरेट कर रही हैं आप इसको?
सर वो यूज़र जितना है 5.
So you're only iterating it 5 times.
दोनों कॉलम से ज़्यादा ना, जैसे कि मैट्रिक्स बन रहा है जो आर बन रहा है हम लोग का, वो रो और कॉलम वाइज इटरेट कर रहा है.
So for each point it is only iterating once, right?
हाँ ये सर.
तो how do we know कि overall error minimize हो रहा है? Fair enough. I mean, okay, ये दिखाइए कि जो आपका जो final matrix बना है, how close it is to your early matrix. जो आपने enter किया था R, original R आपका इतना क्या है? 0301. Let's look at the first row. What's your final R? 94. So it's not the same as जो हम लोग. So at least जो values हमारे थे, it should come close to those values. Okay? You have trained as well. क्या हो रहा है? तो समझ में नहीं आया तो बुलाया क्यों नहीं मुझे? So you have to write your own code now. So let me explain this to you. Sit. So coming back to that. So this is what we have. We have a an R matrix, right? It has got certain values. See, 4 कॉलम ही बनाते हैं. 0, 2 नहीं, एक वैल्यू देना पड़ेगा. 0, 0. Okay, so we can assume this as ये each user का feedback है. और ईच कॉलम पर उन्होंने किसी एक मूवी का फीडबैक लिखा है. लेट्स टेक मूवी या होटल ले चलते हैं. तो हमारा पहले यूज़र ने फर्स्ट मूवी को 5 स्टार दिया, दूसरी मूवी को 3 स्टार दिया. बाकी 2 मूवीज उसने देखी ही नहीं है. He hasn't seen that, so he doesn't know. Our job, and same with every user. So our job is to figure out what might have he given had he been seeing this. Okay. To do that, what we do is that we try to find 2 matrix P and Q whose dot product is similar to R with these values. Okay, so we need to find 2 smaller matrix. This is what we call as matrix factorization. अब क्या करेंगे हम कि हमें तो पता नहीं है, but what we do know is this is 5x4 matrix. Okay, so if it's a dot product, what should be the size of P? 5 by something, and Q should be something by 4. Then the end product will be 5 by 4. Okay, so we start with a random P and a random Q. कुछ random values डाल देते हैं. So now अब हम now in P और Q को multiply करेंगे तो we'll get that error function Eij है. Okay, at every value. Okay, at every value point we will get an error function. E निकलेगा हमारा, और मैं उसके बाद आपको एक फंक्शन दे रहा हूँ कि मेरा अपडेटेड P और अपडेटेड Q क्या होना चाहिए. आपने E कैलकुलेट किया, एक अल्फा और बीटा कांस्टेंट है, दोनों को छोटा वैल्यू रखिए. समथिंग लाइक अल्फा इज 0.002, बीटा इज 0.02 और 0.02. राइट, इनको छोटे वैल्यूज के साथ हम इसको अपडेट करेंगे. फिर अपडेट किया हमने तो एक नया P डैश Q डैश आया. फिर इसका एरर कैलकुलेट करेंगे. एंड विल कीप ऑन अपडेटिंग दिस टिल वी आर सेटिस्फाइड कि हमारा एरर कम हो गया है. ओके, सो मे बी रन इट फॉर 100 इटरेशंस एंड सी व्हाट हैपेंस. ओके, सो कौन सा पेपर उठाए हो, गूगल वाला कि अच्छा शुगर देख रहे हो. क्या पायरेट स्टार सीखे. हाँ, पांडास नॉर्मली SPSS नहीं रीड करता. But all of that is not data actually. Some of this is added. So gesamt means total, right? So some of this is multiple columns added as well. So gesamt is total, that's about it. So आप अगर देखो, so duration, time, motivation, trend, suka 1, trend suka, zucker is sugar, right? उसके बाद there should be something about women or men, and then you have got data with regards to what is the satisfaction total, acceptance total. Okay, and अगर आप पेपर पढ़ेंगे कहाँ है? Not necessarily you can हाँ, it will be good to analyze.
It was easy for me, no?
It will be easy. True. Have you got the paper with you? So if you read this, this is why मैंने इस presentation नहीं दिया है, इसलिए आपको. So this is what that's their model is. So they are looking for कि से 3 तरह के motivator हो सकते हैं. There could be monetary motivator कि आपको पैसे दे रहे हैं भैया. There could be health motivation कि आपका health इससे सुधरेगा. Or there is no motivation, right? कुछ भी करो, हमें फ़र्क नहीं पड़ने वाला, हम खरीदेंगे ही. Right? The other factor could be gender. So they looked at the gender factor. So these are the independent variable. The dependent variable was the degree of self-regulation. कितना आप regulate कर सकते हो अपने आप को. Okay. And then they tested some social science hypothesis based on that. And these are very early results presented here. Essentially saying, this is out. Okay. This is out paper. It's an early studies from this thing, but we have the data set if you can extract any other meaningful information here. And that's why she gave me. हमने जो कहा था, हमने बस early statistical analysis किया था, and all they did was look that monetary motivation acts differently for men and women. Health motivation works differently for men and women, and so does no motivation. Okay. So they did basic order statistic, basic ANOVA analysis, and she wanted to see if we can use any sort of machine learning to extract a better information from this data. So once you read this paper, it will, अगर नहीं बना रहा है, then come and talk to me and I will explain what each line is.
I will definitely take this in.
It's only 3 or 4 pages, so भले 9 पन्ना लंबा लग रहा है, आधे पन्ने तो references हैं. This is
मैं आज पढ़ लूँगा इसको पूरे, तो मैं एक बार डाटा को एनालाइज कर लूँगा, CSV फाइल में कन्वर्ट करके उसको.
okay. So the data has been lying with me. I never got time to work on it. So अब आप लोग देखिए. आप लोग का क्या चल रहा है भाई? आप लोग पीछे छुपे हो, मैं देख नहीं पा रहा हूँ आप लोग को. आप चीनी पर चले गए. Good. What about the code? Matrix factorization. Start कीजिए. आज नहीं तो कब? अगर start नहीं हो रहा है तो tell me, I will sit with you and start it. Okay? What about you? Are you writing matrix factorization or not? Hmm? Okay. Mm-hmm. क्या correlation कर रहे हैं इन दोनों के बीच में? Might be interesting to see if Goldman Sachs has a correlation with, आप किससे कर रहे हैं? The Standard and Poor Index. So SP index generally 500 shares को लेके चलता है. Right? It reflects how the market performs. So Goldman Sachs is well one bank. And there may be. किस लिए कर रहे हैं आप ये? पहली बार सवाल ही मैं ये पूछूंगा. नहीं. The idea was I wanted people to create me a simple module for matrix factorization. No. So अगर आपको हम sparse matrix दे रहे हैं, and I want you to do matrix factorization to give me a filled matrix. So the idea is very simple. Half filled matrix factorization किए कि नहीं आप लोग कोर्स में यहाँ पर? नहीं किए, that's fine. भूल गए. But नहीं, standard में ये नहीं होता है. So essentially it's a sparse matrix हमारे पास दिया हुआ है. It has got some rows and columns. Number of rows and columns is 0. Okay. Can I write somewhere? Pen and paper. पुराने स्टाइल के. So the idea is this. अगर आप नहीं कर रहे हो तो that's fine. So there is a matrix like नहीं, जितना भी कॉलम दीजिए, that's your call. Let's take 5. No. It's rather, if it's not a square matrix is better. And the whole idea is that each row here represents the feedback from a customer. Each column here represents a product. Could be a movie, could be a hotel. The first customer ने हमें first product को 1 star दिया, 2 star दिया, 0 means इन्होंने rating नहीं दी है. And our aim is to figure out what might have been their ratings. Okay, so we have to fill this matrix. No, there's no other information here. That's the only thing which we have. Okay, so this is matrix factorization. So what we do is we go and say, okay, let's try to find a PQ matrix. Okay, of the known elements which are there, we can and let's start with a random matrix. So P has to be, this is 5 by 4, right? So P has to be 5 into something and this has to be something into 4. Agreed? और इसको हम randomly start करते हैं. Okay? तो अगर हमने randomly start किया तो the dot product will give me an error.
Yes.
Right?
The first order.
Yeah. So I've got an error function. Okay? I use that error function to update my element. So it's a gradient descent.
So through that error function we can.
So gradient descent हम plan करेंगे, हम keep on update करेंगे. After some iterations, I should get a matrix where these numbers look like this. This number looks something else. That something else will tell me what this person might have done.
Okay, so the thrown error will give that number.
आइए
Multiple
देखिए.
conditions.
Yep. So it's a classic thing. If you ask students to fill part of the code, it's very easily done. But if you ask to write a code from scratch, it takes more time. 100 iteration में आ रहा है. Good. So a girl has laid claim to the chocolate.
सर जैसे कि वो 0301 था ना,
हाँ.
0 की जगह 3 है, 3 की जगह 2.16 है, और ये 0 की जगह
So आपका अल्फा क्या है?
0.01.
Make it even lower. So essentially, look what has happened. Your matrix was trying to find the minima, but it has moved above minima. तो आपने बड़े step sizes से इसको move किया. So let's move it to smaller step sizes. बीटा क्या है?
सर अभी पहले ही इक्वेशन को
Oh, आपने सिर्फ alpha use किया है. Okay. One of the reasons might be, let's try a smaller alpha. But बीटा introduce करना ज़्यादा मुश्किल काम नहीं है. Right?
हाँ सर यही करते हैं.
Let's see what happens.
सर इस ओरिजिनल रेटिंग में फ्लक्चुएशन ज़्यादा आ जा रहा है. 0 तो पास आ रहा है,
Hmm.
पर ये ओरिजिनल
Okay, so put beta. Let's see. Sorry. See, उन्हें गर्मी लग रही है और मैं जैकेट में परेशान हो रहा हूँ. So, if you are willing to work with the sugar data, नहीं एसी ऑन करोगे फिर ये लोग भाग जाएंगे. आप लोग क्या जैकेट स्वेटर सब कुछ पहने हो. लॉ ऑफ हीट पढ़ा है ना. So if one room में you have got different temperature zones, in due course of time it will. Okay. आप ऑनलाइन कर रहे हो.
देख रहा हूँ बट ये इस तरीके से हुआ है, देखना पड़ेगा इसमें.
इतना आसान होता तो मैं भी किसी वीकेंड में कर दिया होता. Right? It's not very tricky either, but it's just a larger data set than anyone which we have played with. So there's two ways we can do things. If you're very stuck, I can show you a glimpse of how the code will look. Another trick हम लोग अक्सर use करते हैं, you will be see a code for exactly 5 minutes without the ability to take pictures, and then you try to see if you can code it. No? Okay, let me see if I can do that. Okay, let's do this thing. Let me give you half of the code. Okay? And then you can fill in the rest of the half. There are some additional section to let the code converge. So you have my training dot. So how do I share this? Let's create another short URL. So you can see this. Okay. Good. So that particular piece of code, and you can copy, has got everything except the error function and the update function. Okay. So you should be able to copy it and then work on it. So ignore the torch code, that is for a later. So if you are on this page, so everything except the error function, if you look here on the screen, you should have access to this Colab. So the error function is not provided, and neither are the updated values of pi, k and q, kj. Okay. So that should make life easier. You want the short URL? Should I make it bigger? How is it going on? Working. Okay. उससे एक जगह बैठा नहीं जाता. क्या कम आ रहा है? अब डेविएशन कम है. ओके. आपके अपने कोड में या फिर मेरे कोड? गुड गुड गुड. Let me see. So there was a reason I did not make you do the bland simple matrix factorization. Okay, that looks fairly nice. Look. Is it approximately the same? So the numbers जहाँ पर पहले से numbers थे, there it is same. Where you had zeros, is it still having zeros or is it having a different number? So 0.9 is almost 1, right? We can, okay, let's stay. Wait, is it 0.9 or 0.9 something something something? So it's 0.08 in 1, so it's about 8% error. Okay? Fine, it's not bad. But the question is where we had 0 in the original matrix. So what is the first column, row? Let's see. Did you have a 0 in the first row originally? Third column, right? So but originally we had 1.
Yeah.
So it's not bad, it's 4% error, right? So ऐसे मत देखो, आपका 1 चाहिए था, आपको 0.96 आ रहा है, तो कितना परसेंट एरर हुआ? Percent. 0.04 is the absolute error, but is 0.04 in 1, तो error percentage कितना हुआ? Point 0.04 divided by 1 multiplied by 100. 0.04 है, 4%. 40% अगर एरर होता 1 से तो would have got 0.6. Yeah, so if it predicted 0.6, my error would have been 40%. It predicted 0.96, so error is 4%. 4% error I can live with. But the interesting thing is not that. The interesting thing is what are we thinking of this matrix to be? The first row is the feedback from one customer. So if the first customer gave me 5 star, 3 star and another 1 star, if he bought the third product as well, he or she would have given it 4-star rating. Right? So now it's telling me, okay, hey, look, to the first customer, I should suggest him or her to buy 4. I mean, if we assume 2.5 to be the boundary, 2.5 के ऊपर पसंद करेंगे, 2.5 के नीचे पसंद नहीं करेंगे. So now you had loads of 0 in your original matrix. अब आप बताओ कि हम किस कस्टमर को क्या रेकमेंड करेंगे. फर्स्ट वाले को रेकमेंड करेंगे थर्ड मूवी, सेकेंड वाले का कहाँ 0 था?
Second and third column.
Okay, so what will he?
In that we got 3.0
Mm-hmm.
and 4.0.
Oh, okay. So उसको भी हम कहेंगे भैया आप भी दोनों मूवी देख लो. What about the third one?
Third we got 10 in third column. That we got 6.03.
6.03. Okay, so is this the maximum value more than 5?
Yeah.
What's the maximum value here? ओरिजिनल मैट्रिक्स का मैक्सिमम वैल्यू क्या है? 5 है. Okay, fine. It gave a very good. So did it say something which nobody should watch? कि सारे में पॉजिटिव वैल्यूज इसने दिए हैं. So if you started with 0, did it at some point come to something less than 2.5 या सारे zeros को 4 पर ले जा रहा है? So first 0 जो first row में है. Okay, so let's look at the one for fourth customer, right? Originally it was 1004.
At 10 we got 5.02 and in another one we got 1.06.
So no, not the fifth. You're looking at the fifth customer. I'm looking at the fourth customer. The fourth row. So what was your original?
1004.
So 1004, right?
That was original.
That was original. What did we get?
First 0.99,
That's okay.
then 1.06 at the place of 10,
Mm-hmm.
then 5.02.
Okay, maybe she has got a different, slightly different number. But look for this way. If there was a second column was one movie, it is saying that this customer would have not liked that movie. So there's a choice between second movie and third movie. Which one we should recommend to the customer? The third movie. Okay. So that gives us one idea of how we can make a recommender system. ठीक है? Oh, good. You have got tons of numbers to play with. Right. Has everyone got their matrix factorization working? So you guys have got it. What's the status of you guys? It's not working? So let me come and have a quick look. We can solve it using, so this time we have used a gradient descent. There's also a regression based or OLS based method we can do. And then you can ask, there are already a large number of such problems solved, Netflix problem being that, right? Why can't we use their database and train a neural network to do it? It will give a slightly better fit, be quicker, because gradient descent is slow, sometimes does not reach the minimum optima, right? Depending upon the size of the step size you have given, it could jump or could overfit. Okay. Control better optimize this. And the size, आपका size अभी बहुत ही छोटा है. Okay. So the model could then be used to so the first work where this happened was I think in 96 or 97 when Google came up with a wide neural network and a deep neural network, a combination of a wide neural network, and it's a wide neural network was just one layer but many wide columns, and plus a deep neural network, and you add both of these two to do matrix factorization easy. And after that there have been many papers on purely deep neural network or different approaches to do it in a different way. Actually, it's not just matrix factorization, it's a recommender system, how to build a recommender systems best using these things. Okay, let me look at these guys. क्या हो रहा है जनता? Sorry for removing your bag. अगले जन्म में पाप मिलेगा. No, but they are not to be constant. क्या है हमारा error function? How do we calculate the error function? अगर आप constant दे दोगे तो हमेशा constant error होगा. तो हम हर iteration में क्या कर रहे हैं? We are coming with a new value of p and q. Suggest भी कर रहा है cheater Google. नहीं, Google suggest कर रहा है basically. Right? So that, what does that say? My current Rij minus the dot product of Pik and Qij. Okay? So that's the error. अभी जो हमारा matrix है, okay? तो the original matrix जो था, हमारा P and Q अभी predicted matrix है. The original matrix minus my P and Q matrix. Okay? Oh. And then हम क्या करते हैं? We create new values of Pik. We take the original value of Pik. अल्फा हमारा ग्रेडियंट बता रहा है कितनी जल्दी हम कन्वर्ज करेंगे, राइट? तो वी टेक द ओरिजिनल वैल्यू ऑफ अल्फा प्लस 2 टाइम्स एरर टाइम्स क्यू के जे हमने जो इक्वेशन डिराइव किया था सवेरे, and plus एक बीटा वैल्यू which is another from the same value. And same we do for q. So हम essentially हर इटरेशन में p और q को अपडेट कर रहे हैं. हमने p और q अपडेट किया तो अगले इटरेशन में एरर अपडेट हो जाएगा. और हम करना क्या चाह रहे हैं? हम ओवरऑल एरर को घटाना चाह रहे हैं. तो हम ये कह रहे हैं कि जो एरर एसेंशियली कहना ये है कि अगर हमारा एरर पॉजिटिव है, बड़ा एरर है, तो पी और क्यू को छोटा करो. एरर छोटा है तो पी और क्यू को बड़ा करो. और यही छोटा बड़ा करते 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 ऐसी चीज़ में पहुँच जाओ जहाँ पर आपको ये हो जाए. सो लेट्स सी हाउ डज दिस वर्क. एक्चुअली नो व्हाट, ओके, यू हैव गिवन काम कर रहा है कि नहीं? So now let's compare this to our original matrix. So 3 था, हमने 2.97 आया. 0 की जगह 2.23 आया. So we can think of it this like this way. So each row represents the feedback of a customer. तो पहले customer और each column represent a product. एक मूवी रिकमेंड कर देते हैं. पहली मूवी को हमारे पहले कस्टमर ने 3 स्टार दिया और आखिरी मूवी को 1 स्टार दिया, और दूसरी और तीसरी मूवी को उसने देखा ही नहीं है. अब हमें डिसाइड करना है कि उनको रेकमेंड करें कि नहीं करें. हमें तो पता ही नहीं उनको अच्छी लगेगी या नहीं लगेगी, राइट? नाउ my this factor says after doing this whole, my first number comes 2.97 which is close to 3, last number is 0.99 which is close to 1. If you look at these two numbers, एक में उसको 2.23 दे रहा है, दूसरे में 0.04 दे रहा है. Considering my maximum number goes up to 9, that's a little bit high, but if you pick a threshold, say 2.5, so 2.5 से नीचे अगर मेरा prediction है और या 2 से नीचे prediction, then most probably a customer movie like नहीं करेगा. So going by this strategy, this customer will not like the third movie. He may like the second movie. तो अगर हमारे पास 2 ही प्रोडक्ट हैं, 2 वो खरीद चुके हैं, तो हम ये वाला रेकमेंड करें उनको कि सर आप शायद ट्राई कीजिए, राइट? सेम फॉर द थर्ड कस्टमर को शायद पहली मूवी अच्छी लगेगी एंड अगेन थर्ड मूवी अच्छी नहीं लगेगी. एंड यू सी वन ऑफ द रीजंस व्हाई दिस मैट्रिक्स हैज डन दिस वे कि थर्ड कॉलम बहुत लोगों ने देखा ही नहीं है, राइट? अच्छा, दैट्स अ वेरी गुड, मैं अभी बात करूँगा. तो थर्ड मूवी वो किसी ने नहीं देखा, हमें नहीं पता किसको अच्छी लगेगी वो. ओके, लेट्स डील विद दिस नंबर हियर. आर यू डन? कैसा चल रहा है? So let's think of this as a matrix factorization issue, people. So let's try to understand the meaning of this a bit. So I've gone and talked to each one of you individually that we wanted to see this as this matrix represent ratings given by a customer for different products. So we can think of each row as a customer and each column as a product or a movie or a hotel. So my first customer has given 3 star to the first product, 1 star to the second product. And there is a very, by chance, the third product has only been seen by one customer, okay, who by the way only likes this and does not like the other two. So it is a very difficult matrix, so any result. Now what we have got after doing all of this is a value like this, okay. Now we can think of it in this fashion. So we're trying to make a recommender system. Now we know our first customer has bought the first product and the last product and gave it a 3 star and 1 star. 3 star, let's assume that a good number. Anything above this, the maximum rating is here is 4. So let's assume anything above 2 is good, anything above 2 is bad. So he or she liked the first product, did not like the last product. Now we have 2 more products to offer. Which one should we offer to this customer, or should we offer both? So going by these numbers, it believes or it thinks the customer may like the third product. It has 2.71, will certainly not like the second product, is 0.06. And one theory which you can see here, so the only customer who has seen the third product is the last customer. Okay? Who has not seen the first product, has seen the second product which has not been seen by the first customer either, but has seen the last product and has given a rating which is close to the first customer. Okay? So one assumes that the rating given to the third product or तीसरी movie को compared to the will be similar to this customer. Okay? And subsequently gone. So in this, if this was true, we could try recommending this product to the first customer. Bhaiya, watch the movie number 3, you may or may not like it. But this is prone with errors because there's very little data for this customer, for this product at all. Sirf ek hi log ne dekha hai, we are going with very blind. So why don't I change it a bit and see if that makes it any different. So I've changed my original matrix and said, okay, customer number 3 also saw this and really liked it, but customer 3 did not like the first product. So customer number 3 is exactly opposite to customer number 1. And actually what the product says to virtually every customer here. And one argument you might have, hold a second, 2 people saw it, they both liked it. So is it something which is universally liked? So that's how you can make a recommender system from here. Good. Take a break or continue? I'll have some discussion and then I will leave you in peace to finish it. Continue? Good. So what I wanted for you guys to try is, we tried a very simple matrix factorization for a small matrix. Right? So I've given you a link for a large matrix which had just got the rating. So let's see if this works. So this essentially is a data which says this particular user for this. Why is this proving to be annoying? भैया आपका ये feedback दे रहा है. Okay, ठीक है, अभी चलते हैं, देखते हैं. So this basically has a ratings from each different users for different user items. And you can see there are a large number of user IDs, there are a large number of item ID, and we have ratings. This is a very sparse matrix. Okay, so you might have one user just providing 1 or 2 items in this 10,000 matrix. So one thing which you can then try to read this, convert this into a 2D matrix, and then try to do matrix factorization and see if your code works or not. So that will be your offline assignment. Let's finish some discussion here and then we'll come back to it. So and herein I wanted to give you an example. So remember I've said we'll analyze a paper, one of the papers which I wrote. Do you have energy to analyze it today, or do you want to do it tomorrow? Sorry? Can't hear. So I said, do you have an energy to go through and listen me talk about a paper which we wrote about price sensitivity, or do you want us to do it tomorrow? Today? Okay, good. So we wanted to ask the question that price is a motivator for customers, right? How do we do that in supermarket settings? So one aspect of the problem was, will a person like a product or not? Other aspect to ask, if I reduce the price of this, will the person like it or not? Or does the price of some products matter? Or if which products matter in a supermarket? Does changing price of everything matters to every customer the same way? No. Which customer matters to what and how does it go? Okay. So we want to make a price-based recommender system. And here are some punchlines on. Okay, wait a second, guys. This is too noisy for my ear. Okay, this should work. Can still get the sound right? आपको sound आ रहा है भैया? Good. So before you make a recommender system, you need to ask yourself कि करना क्या? What is the aim of making this recommender system? Do you want to increase sales? Do you want to increase the speed of sales? Do you want a person to be able to buy the product faster? Or do you want to engage with your customer? Do you want to know more about the customer and get him involved with it? That's the first question to ask. The second question to ask is कि data कहाँ है? किस तरह का data है? कितने percentage of end user हमको data provide कर चुके हैं? Okay? या फिर हमको नया data collect करना पड़ेगा? Do we need to create some sort of a loyalty card scheme to collect new data? और अगर करना या फिर the kind of sugar data which we have given you, basically लोगों को खड़े करो supermarkets में हुआ collecting feedback based questionnaire. Okay? The other question which you have to ask is, are all my products equal? क्योंकि अभी तक हम जो देख रहे थे, हमने हर कॉलम में अगर हम 4 मूवीज कंसिडर कर रहे थे, all columns meant exactly the same to me. Now, if I'm a movie business, they might mean the same. मतलब सबका एक ही टिकट लगाएंगे हम. But for all businesses, that's not true. कुछ में ज़्यादा product margin होता है, कुछ में कम profit margin होता है. And final चीज़ ये है कि हम customers को segment करने जा रहे हैं. Right? We are going to put customers in different pockets. What is the feature which is similarity feature between them? क्या उनको unite कर रहा है? What is the thing which is common between them? Okay? So हमें इन चीज़ों की जानकारी होनी चाहिए. And once you are at the data stage, you need to collect data. So how are you going to collect them? What kind of data do you have? Do you have customer feedback? Do you have customer ratings? Is it a numerical rating? Is it a qualitative feedback? If it's a qualitative feedback, how do we convert it to a numerical rating? Okay. Then we create our recommender system, but no recommender system is ever perfect. Basically, it's a statistical measure, so you need to keep on iterating it and keep on refining it based on the data which keeps on coming. Okay, so it's not trained once, used many times, but it's a continuous evolution. More so because your customers are not static. वो भी evolve कर रहे हैं time के साथ. The problems with many of these is there is no way to evaluate it. So हमने recommend किया आपको product. हमने एक recommender matrix बना लिया कि ये customer ये like करेंगे. Unless उन customers के पास हम data ले जा रहे हैं, हमें priori evaluation का कोई तरीका नहीं है हमारे पास. Only when a customer likes or dislikes, he has given me new data, then I know whether my system works or not. तो तब तक हमने काफ़ी खर्चा कर दिया है. We have made a whole system, पूरा database के. So we don't know in any way whether this evaluation system is suitable or not. हम customer की बात बार बार कर रहे हैं because customer and movies make sense to all of you, but it could be any kind of recommender system. Okay. The other thing is how does it scale? हमने 4 प्रोडक्ट का रिकमेंडर सिस्टम बनाया था. हमारी दुकान बढ़ गई और हमारे पास अब 6 प्रोडक्ट हैं. अब जो 2 नए प्रोडक्ट हमने लाए उसके बारे में तो हमारे पास कोई फीडबैक नहीं है पहले से. तो हाउ डज माई सिस्टम स्केल? And the other thing is, if I made a recommender system for one type of product, can I use data or similar learning or same profile for another type of product? Yes, no? So say I have got a movie-based recommender system, okay? And I am Google, and I also have got the Play Store जहाँ पर हम recommend करते हैं what games for you to download. Can they be related with one another? The girl says no. Does anyone say yes? Well, it is well known people who are in the science fiction industry, fiction movies, they like playing fiction based computer games. Right? Not all people like me who don't like fiction games. Okay. So that's the next question to ask. For every product, do I need to retrain my data? Because training takes a lot of energy, whole data has to be collected. Okay. So, back to our study. We started with a model called shopper model, which tries to mimic what does a shopper do. And it gives a hypothesis. The hypothesis is a bit strange, wherein it says that every customer kind of makes up a product. When you walk into a superstore and you find a product, you create a probability whether I buy it or not. And then you decide that if there's a next product which comes, you compare between these two. And the customer is a bit myopic. He doesn't see the whole store, which is a bit problematic, but it's not the worst of the world. So we started from there. And we got a customer, and we are going to do matrix factorization. Our matrix factorization was not as straightforward. We did use a deep learning based enhanced matrix factorization. So we had a deep learning layer on one side, we had pure proper matrix factorization on the side, and we added them and then took a sigmoid function to get the output. I'm not going to delve deeper into how we did that, because what is interesting are the results which came out of the study. So look at a large supermarket chain in Germany, which sells a large number of different products, vegetables, meat, eggs, personal care, etc., etc. And looked at their transaction history of 23 months. I'm going to give you a flavor of the amount of data which is there. So the study was led by Dr. Vinay Singh, who works currently for a different firm. And the idea was that we looked at the customers who had purchased products at one or more stores of the supermarket. Okay, so it has a chain. So we first clustered the data set based on the frequency of customers, kitni baar wo aa rahe hain, and we ended up with about 17,800 products for 2,000 customers. So fairly large data set. Okay. And when we grouped them into different groupings or different bar ke different time wo hamare stop mein aaye the, we ended up with roughly 107 different groups, with a total number of transactions being 1.2 million. So we have 1.2 million data spots. And for each transaction, we have what products they have bought and at what price they have bought. This will give us their price ghata badha, so did they start buying more. Okay. So we did the recommender system. We looked at if the price changed, how are they corresponding to price, and overall this is what the result we got. So herein we are plotting the price sensitivity versus your customer preference. कि हमें ये चीज़ खरीदना है और versus अगर price कम होता तो खरीदते. किस चीज़ों पर हम ज़्यादा price sensitive हैं और कुछ चीज़ों पर we don't care. So you can see there are products जिनमें we have got very high customer preference, and the price sensitivity there is a bit lower. So to explain this further, so look at these products. So these have got high preference but low price sensitivity. Okay. So these are products like bread, milk, salad, butter, vegetables, eggs, newspapers. There's a very interesting thing here. These are the products जो हम वैसे भी खरीदते, right? अगर ब्रेड खरीदना ही है 5 पैसे किसी दूसरे दुकान में कम मिलेंगे तो maybe we will not think too much about it. And these are everyday product items. These are also the product items which we buy more. General purchase हम ज़्यादा करते हैं. तो इन पर our data says that there is low price sensitivity. अगर आप price बहुत change भी करोगे तो it doesn't make much of a difference to a customer. Okay. So these are widely purchased products, and if they are necessities for life, price plays a role but not as much as a role it plays in something else. The next data, so it's all from the same matrix factorization. We have now got the figure. Rather than boring you with the whole detail, I'm just looking at the results now. So here are some other products where we have low preference but high price sensitivity. So these are cheese, canned foods, frozen foods, nuts, paper towels, and that kind of thing. So हम खरीदते हैं इन चीज़ों को, but immediate preference नहीं है. But here I am highly price sensitive. So these are products of convenience. They're not freshly produced. आज नहीं खरीदे कल खरीदेंगे तो भी काम चलेगा. Okay? And they have low preference for customers. There's not immediate need, and there it seems there is high price sensitivity. Then there are products where they have got very high price elasticity because वो सिर्फ यही नहीं और भी जगह मिलते हैं. So look at things like hair care, lip care, baby food, sweets, tobacco, and other things. So इनके साथ क्या है कि there is an alternative availability. अगर आप हेयर केयर फार्मेसी से भी खरीद सकते हैं, कन्वीनियंस स्टोर से भी खरीद सकते हैं, सुपरमार्केट से भी खरीद सकते हैं. सो इनमें वी फिगर आउट पीपल ओनली बाय देम फ्रॉम ए सुपरमार्केट अगर उनका दाम कम है. खासकर मेडिसिनल प्रोडक्ट यू थिंक कि मेडिकल शॉप में ज़्यादा अच्छा होगा. दिस यूज टू हैपन विथ हॉर्लिक्स बिफोर. आई डोंट नो व्हाट्स द स्टेटस नाउ. कि हॉर्लिक्स दवा की दुकान से गिर जाती थी, मेडिसिन है ना. उसके बाद सबको एनर्जी देगी, हमारा दिमाग बढ़ाएगी. दिमाग तो बढ़ा नहीं, पैसे जरूर चलेगा मेरे. ओके. So this was the three grouping of products which we did from a supermarket point of view. So now we know there are some products on which price matters. There are some products where price could matter, and there are some products where it doesn't matter too much. But now we have looked at broad scale of products. Okay. We also did a bit deeper study and looked at is our data being biased with the volume of purchase which is happening and with customers who buy too much, or are there different price sensitivity for customers who buy too much or customers who buy too little. So in my shop there will be customers who will buy 2 kilos of potato, others will buy half a gram of potato, or not half a gram, a smaller volume of potato. So we then looked at people who did major purchases versus people who did minor purchases. And then looked at their price sensitivity. So not surprisingly, people who did less purchases, who had less preference for vegetables, say less than 0.5, their price sensitivity was higher than people who did more purchases of vegetables. So जो कम खरीद रहे हैं उनके लिए प्राइस ज़्यादा मैटर कर रहा है, तो जो ज़्यादा खरीदना तो खरीदने ही वाले हैं. And same thing happens with meat as well, though the numbers are slightly different. The other thing which is different is, if you look at the preference versus the amount of purchases in vegetable section, the number is very oddly placed. So it just goes to show that customers who have high price sensitivity but low preference could be motivated to buy these low preference product. उनको price का sensitive offer दिया जाए तो उनको मीट नहीं खरीदना था. Well, not if they are vegetarians, but if they are non-vegetarians and meat नहीं खरीदना था, but उनको preference नहीं था, then we can give them an offer to convince them to buy this product. Okay. It still doesn't tell me about individual products, and this is one the other trick which you can do to showcase. Now this is a data visualization exercise. You can do a heat map of products. So we've done a heat map of 10 random products for some customers. So on bottom we have got customer number. On this side we have various products which can be purchased. And darker the product, the more sensitive that customer is for price there. Now look at products like cucumbers. It's all light here. What does that show to me? I have no price sensitivity, right? अब जो भी करो cucumbers खरीदेंगे ही, या फिर early meal tomatoes, there is very little price sensitivity. So it goes to show कि in these products को आप कुछ भी कर लो, promote करना बड़ा मुश्किल होगा. Maybe, but from this data suggests promotion is tricky. But there's some products like herbs, lemon balm, they have got fairly high price sensitivity. And there, maybe if you do some promotion, you will get people who will buy it more. Remember, this is data from Germany where spices are bought in a bit less amount than in India. इंडिया में पता होता है कि मसाले ही सबसे ऊपर में है, मिर्ची खरीदनी है भले ही 100 रुपये किलो हो या फिर प्याज खरीदना ही है. So this data is sensitive to where it comes from. Okay. So इन products में आप कुछ margin दे के शायद अपना ये बढ़ा सकते हो. And something similar goes for meat. Now in general, meat has got fairly high market price sensitivity, and this is a question which I wanted to ask to, and if there are meat eaters in the hall, is it a very price sensitive market in India as well? Because we know vegetables are not price sensitive. I mean, onion का दाम और गाली के दाम पास में बहुत ज़्यादा बढ़े थे और लोग फिर भी खरीद रहे थे क्योंकि सब्जी नहीं बन सकती. What happens to meat? Is it price sensitive? So, because options always a vegetarian बनने का temporary vegetarian, right? Okay. What is interesting, there is some products like ham and tulip bacon which are very much a ready day-to-day use product. They don't have much price sensitivity here. Okay. So we did this study for a German market, and now I'm showing you how matrix factorization helped us figure out not what a customer would like, but what a customer may like if we change the price. And let's stop here. Okay. So we recommend, so the end goal of this project was fairly interesting. There was a paper published in Journal of Retail Journal of Retailing and Consumer Services. You can read the full paper. It is freely available for you to download and appreciate how we went through and what we went through. The work primarily done by Dr. Vinay Singh and his team. Strategy for us, now it tells us something about larger supermarkets. The question then comes, how does this data translate it to other markets? Can we translate the data as it is to the Indian market? What about vegetables? Will it translate to Indian market? Would there be any similarity based on the dietary habits? Potato might. What about cucumbers? Kheera. You don't think so? But there will be products which will buy rice for that matter. So do we have price sensitivity for rice? And are you telling with experience or based on data? Because, so one of the early thought process we had was, it's a German supermarket, they will not be price sensitive to meat. But that's not always true. Okay. Now, we have only looked at price sensitivity right now. There's another aspect of this thing. How will my customer come back? Will there be a survival of the customer? Okay. And there's another theory which me and Vinay are trying to postulate here, which I will discuss with you tomorrow about how we can ensure or how we can measure the lifetime of a customer. So generally we currently measure customer as based on its purchases. We are now trying to think of customer as more like a diseased value, जो प्राणी मरने वाला है. So अगर वो जितना देर तक जिंदा रहेगा उतना देर तक हमारी दुकान से खरीदेगा. जब वो नहीं खरीद रहा है तो it's as good as dead for me, isn't it? Right? If customer हमसे नहीं खरीद रहा है तो I am dead for it and it's dead for me. Okay. Good. I will stop here today. Unless you want to, हम लोग काफी heavy dose कर चुके हैं. I'll be here for another 20 minutes. We'll go through if anybody wants to update on their code, or if you want to run the big database, either this database or download any movie database. I mean, there are tons of movie databases to download free on places like Kaggle, and see if the simple matrix factorization code which we developed a bit earlier, does that do the trick? And It'll be also interesting to see if you are one of these customers, because you yourself know what you like. Does it still tell you any movie which you have not seen and is there? Okay. So if you go here, there are tons of such simple things which you can download. So any one of these, and see if we can make this is the big one, the movie lens data set, but that's a huge data set. Oh yes. So this goes through some, I mean, how many movies it goes through? Okay, fairly decent number. So maybe something like this you can download and see if you can play with it. Okay. Right, I will stop, but I will be here for next another 20 minutes to talk to you. Okay. So tomorrow's case study will be slightly different, and that all depends upon what state of mind I am in tomorrow. So the original case study was planned to look at yield analysis in manufacturing process. So yesterday we looked at banks, financial data. Today we looked at recommender system. This 5 days is about giving you flavors of different type of systems. Okay, because there's no way on earth we can finish all the 5. So tomorrow I will look at a different set of things, which is I'm making large number of products. How many of these products will be satisfactory to my customer? Okay. So we'll again go back and look at design process. So I'll be doing a bit of theory on how chips are made. Only then you can appreciate why we can have so many faults. Okay. We will then look at the faults which could be. I will again give a report on the studies which we have done with a large database and the results which we have made. But what I will make you do will be, I will make you learn the same algorithm, but then play with much smaller database here. So we will do random forest tomorrow and see if I have got energy to do. So we'll, if we can do a class as well. Okay. Good. Thank you very much then.